الأولى لليوم بعد قليل. Good morning, Your Excellence, distinguished guests, ladies and gentlemen. We will start our next panel in a few minutes. أصحاب السعادة، الضيوف الكرام، سيداتي سادتي، السلام عليكم ورحمة الله وبركاته. Good morning, Your Excellencies, distinguished guests, ladies and gentlemen. It's a great pleasure to welcome you all to our second day of the forum, Powering the Future Toward Net Zero, organized by GCCIA in collaboration with EPRI, GO15, and MED-TSO. Let's start the day with welcoming our moderator for the panel session, Variability Challenges and Flexibility Solutions, Mr. Daniel Brooks, Senior Vice President of EPRI. Joining him are the speakers, the esteemed panelist, Carlos Gasco Trafazeto, Executive Director, Department of Energy, Abu Dhabi. Engineer Bruce Smith, Director Planning, EWIC, Abu Dhabi, UAE. Dr. Lumi Adisa, Director Energy Systems, NEOM. Mr. Angelo Ferrante, Med TSO Secretary General. Mr. Mikael Halonen, Application Engineering Manager for Grid and Power Quality Solution and Services, Hitachi Energy. And on the stage, we welcome Dr. Majid al-Rashidi, Research Scientist, Kuwait Institute for Scientific Research, Kuwait. Welcome to the stage, everyone.
Good morning. Helps when you turn the microphone on. Hope everybody had a great day yesterday. I thought we got off to a great start, a lot of good conversations. And we're going to jump right in first thing this morning with flexibility. Topic came up yesterday throughout almost every conversation. Not just every conversation, but almost every speaker mentioned renewables and how important renewables are going to be to the future that we're looking towards. And when you talk about renewables, you got to talk about variability and uncertainty. And when you talk variability and uncertainty, how do you manage that in the system? And so as we displace those traditional dispatchable resources that have provided those grid services for us in the past, we've got to find those sources of flexibility from other locations. And that's what we're going to do this morning with this distinguished panel. We've got all types of perspectives, and I just want to jump straight into it and not waste too much of our time. So want to start off and have each of the panelists just give a few minutes based on their own perspective. And so I'll sort of set that up with a question for each of you. But Carlos, in Abu Dhabi, with your decarbonization aspirations and targets, what do you see the need for flexibility looking like and how that need's going to change over the next 5 years, but then the next 15, 20 years as well?
Right. Thank you. Thank you so much for the question. And first of all, let me say that it's great to be here, to be able to share some ideas, some thinking, and hopefully get some questions and some debate with my fellow colleagues here in the panel. Indeed, I think you just actually nailed it. The electricity systems are changing very quickly. In Abu Dhabi, in particular, we're going from a penetration of clean and renewable sources of almost nothing a couple of years ago to 65% in 2035. Today, we are already around 40%. So this is a challenge, a real challenge, because we are dealing with variable renewables, mostly in the form of PV, also some wind now. Plus a relevant base load of nuclear power, which is very stable but also rigid, and we're changing the way in which the thermal generation was used from base load to providing the flexibility. In addition to that, we're quickly also moving into the procurement of battery storage to give us some of that flexibility, the additional flexibility that the system needs. So when we look at this together from a policy making and regulatory perspective, we basically have to make sure that at every instant supply and demand meets in a way that is new to the system. And for that, we have enhanced different, let's say, enablers. We have made institutional arrangements, and we will continue to upgrade them to make sure that the needs are met, and with a greatest degree of accuracy. So to do that, we have to look at the supply, and we need to look at the demand of electricity. And for the supply, we need to make sure that the planning process that we have in place is consistent with the technical needs, with the capabilities of each technology, with the accuracy of the demand forecast, with the variability within the day. And then we need to make sure that all of those things are put together in a way that the system operator, which is represented by my colleague here, Bruce, can manage, in a sound way. So we need to upgrade our systems, and then we need to start also looking from the demand side to what extent we can adapt not only the way the electricity flows one way, but also the way that the electricity is demanded at the consumer end. And to do that, we have a energy efficiency and demand side management program, which is providing additional flexibility also from the other side of the story, which is usually forgotten. So in a nutshell, we need to carefully understand the implications from a technical, from an institutional arrangement point of view, and from an economic and price signaling point of view. All of those things together are going to give us the answers which we need, which will continue to evolve as the technologies evolve, as the demand evolve, as the electrification of different sectors like transport or industry continues to grow. All of those things, all of those ingredients will be put in a package. And hopefully, with those efforts, we will make sure that we decarbonize, we keep the grid stability, and we make it at a competitive rate.
Oh, yeah. So I'm sure there's a lot of comments for that. I want to get to each
hope
one,
so.
and then we'll come back. Yeah, so you covered it all, from existing resources to new resources to the demand side supply. Bruce, I know at EWEC you guys are procuring sources of flexibility already, particularly batteries, looking at that as one source. And what are some of the drivers there that you're considering that are moving you towards that source of flexibility, and what do those deployments look like in the near term?
Good morning. Thank you, Daniel. It's a pleasure to be here. So the planning team that I lead is basically responsible for identifying how do we make the transition to a system that is going to contain a lot more renewable, clean energy. Why? Because we have 3 planning mandates. Security of supply, which really acts as a constraint in terms of planning, least cost, and decarbonization. Now, decarbonization is not a constraint. It's not driving us to do something that we wouldn't be doing if we weren't already trying to deliver a least cost system. A least cost system contains a lot of solar PV in this part of the world. It is the cheapest source of energy. So by 2030, we are looking at something like 57% of our energy will come from the combination of the nuclear that Carlos mentioned, plus solar. 57% within 6 years. That means that for virtually every hour of the day when the sun's shining, we are going to need to be utilizing to the maximum extent possible how much solar is integrated into the system. So flexibility is absolutely key. In addition to the fact that the sun obviously sets each day and rises each day, so we're going to have to go from full solar to no solar. We're going to need to manage those periods when it's cloudy and the wind's blowing hard and there's a lot of variability. Omar's in the audience today. Just in the last 2 months, we've been facing situations where over a 20-minute period, we go from 1,200 megawatts from solar to 0 and back up to 1,200 megawatts in 20 minutes. We're not capturing that in hourly modeling at the moment. Lumi's nodding his head. He's facing exactly the same challenges when he's trying to foresee what's going to happen in NEOM. So 57% clean energy by 2030 means that we need to be able to run a system and have the control systems in place that will enable us to be able to reliably dispatch close to 100% clean energy during daylight hours and manage that variability. So flexibility services, how do we maintain grid stability? How do we provide that frequency support, that voltage support, voltage stability? How do we do that is absolutely critical. If the control room doesn't have the tools that will enable it to reliably operate at close to 100% and manage that flex variability, then we won't manage it. So what are we doing? We're in the market at the moment, have been for some months. We expect the bids back in November, so with just a few weeks, for 400 megawatts of primary reserve, or batteries that will provide primary reserve, in effect, fast frequency response. So these batteries will replace the reserve providing, the grid stability providing services that have, up until today, been provided by gas generation. So within 3 years, we will be able to turn the gas off and use the batteries to provide the grid flexibility services. Why aren't we buying batteries for energy arbitrage? Well, simply because at the prices we were assuming at the start of this year, it wasn't in the money. At the prices that we are now being indicated, which have fallen nearly 50% over the last 9 months, we're seeing that batteries plus PV is now very close to the same price as gas-fired generation from CCGT. We are at that inflection point when we can make that transition and stop burning gas at night and use batteries together with PV if we've got the land. So I'm conscious of time, Daniel, so I'll stop at that point.
Yeah.
But that, in a nutshell, is we're using it for flexibility services today. We will be using batteries and storage for arbitrage very shortly.
Yeah, very interesting, and we'll come back to a couple of those points. Transition to you, Lumi. So, Bruce, Carlos both talked about transitioning the existing system. That's not your problem, right? No. Yeah, you've got a unique situation where you've got to design a new system from the bottom up. What are the flexibility considerations for you, the unique opportunities and challenges with that?
Yeah, thanks, Daniel, and thanks, everyone. Good to be here. It's quite unfortunate sitting next to Bruce because he's mentioned all my points. But I think the key difference, we have very similar objectives, actually, close to what you're looking at UEC. For us, we have the same low-cost system, security of supply, except we're not looking at 57% by 2030. We're looking at 100% by 2030. So the scale of that challenge for us is a bit different. The other key interesting thing for us is we're not retrofitting an existing system. We're building one from scratch in NEOM. So it's almost like you're having to fly a plane whilst at the same time you're building the plane, right? So our challenge is slightly different. But for us, we're looking at the same things, solar, wind, storage, including pumped hydro storages and batteries to provide that flexibility. But there's a really key point that Bruce mentioned about the weather impact of going from 1.2 gigawatts of solar to 0 in a couple of minutes. So we've been able to do a lot of analysis on that. We've partnered with EPRI as well on this, so we've been doing a lot of resource adequacy studies. And one of the things we found is that there are a lot of dust storms in the NEOM area that happens about 1 to 2 years. And one of the things we are seeing there is if you have a 100% renewable system in this part of the world, as Bruce mentioned, it's going to be solar dominated during the day. But the interesting thing is our flexibility studies like pumped hydro and batteries, they don't provide energy on their own. They store what's there to bring it back on. So when you have these dust storms that reduces the capacity of your solar, then there's really nothing you can cycle in the nighttime. So we really have to oversize the system, have a long duration energy storage, but the $1 million question is, how long does it need to be to cover a 3 to 4 day dust storm? So we are starting to think about other technologies like demand response to provide flexibility. So can we have customers part of our energy system? So we've currently kicked off a work program with all the new customers coming into NEOM to rethink how they can design their manufacturing equipment. So I worked for AEMO in Australia, and back then in Australia, you would have one pot line of a cement factory that's 300 megawatts, right? But now we're saying to the customers that are coming into NEOM, can you modularize your equipment? So instead of having one large equipment that consumes 300, can you have 10 of 30 megawatts? So when we have this variability, you can modularize the demand storage because the cheapest source of energy is the one you don't have to invest in. So we are now starting to bring in a lot of this demand response, batteries for the very short, fast frequency response, primary frequency response, and things like pumped hydro, and also LDES, long duration energy storage, for that longer duration that we need. Then the other thing we're also doing is, because we have the luxury of designing the system from scratch and not retrofitting it, can we even design the grid differently? So instead of going to an AC grid, can we go to a DC grid? So right now we're thinking about having a DC grid that allows us to minimize the expenses we would need for system security services for things like voltage support, system strength, and whatnot. So we've actually signed a contract with the provider to be able to give us that DC grid as well. So for us, the challenge we have is we have to build something from scratch that doesn't exist. It has to be 100% renewable. You have to work with weather. How do you do that? Then the second challenge we have, which can also be an opportunity, is if you don't have to retrofit something that exists, you can leapfrog some of the legacy issues and go straight into the future. But that also comes with a lot of risk. There's no DC grid in the world at that scale. There's no 100% renewable grid in the world at that scale. So doing those two things together in 5 years, is that something that's actually possible? But for us, that's what keeps us awake at night, for sure.
Yeah, that's why you got the bags under your eyes, right? Not sleeping. Thanks, Lumi. Appreciate that. Angelo, You've got the experience of many of the TSOs around the Mediterranean, and particularly there with Italy, in Terna. What are you seeing in terms of flexibility, resource? What are your experiences? What would you share that here's some things that you might want to do and some mistakes not to make as you're sort of moving towards that flexible grid?
First of all, can you hear me?
There it is.
Okay, first of all, good morning. Yes, indeed, as a representative of MetTSO, but also as a coming from the Italian TSO, I have this double experience of very strongly regulated environment. That's the European context where there is a strongly meshed system that serves more than 500 million inhabitants, with the experience of the Mediterranean, that's a region very close to the Gulf countries, that intends to cooperate with the Gulf countries where the integration is very low, but several problems are similar because in any case the power system is going through a tremendous change from a unidirectional flow of energy to a bidirectional flow that obliges the TSO to guarantee the former services that it used to guarantee in the traditional context, security of supply, quality of supply, resilience, sustainability, in a context where there are enormous new challenges that oblige the TSO to use, let's say, a kind of toolbox to guarantee these services. This toolbox is made of several factors. Flexibility is one of these, it's not the only one, because the development of the grid is essential also for promoting the integration of renewables. Also, market design is important because we as TSO are not directly involved, but we should promote the actions that facilitate the integration of renewables also in terms of services provided to the system, and also digitalization, innovation that can favor the integration of renewables. In Europe, the targets are very challenging. For instance, in Italy, at 2030, we have to accommodate in the system more than 74 gigawatts of renewable energy, according to the National Energy and Climate Plan, to reach the threshold of 65% of RES share in the production. And this is really challenging because it's more than 40 gigawatts of new renewables compared to the actual situation. So flexibility for sure is one of the most important tools for facilitating this integration. And flexibility should be guaranteed in all the time spans, because the services that the TSO provides, especially in terms of adequacy, must be guaranteed in terms of hours, in terms of minutes and seconds, in terms of real-time operation of the system. In the short term, in the daily management of flexibility, particular relevance for us is storage, together with demand-side response. As TSOs, we are very much interested in storage that can provide the right solution for, there is a fly that likes me. But the problem of storage is that, unfortunately, the spot market alone do not provide the right signals for an appropriate development of what is necessary. I wanted to open a parenthesis on the Mediterranean as an association that fosters the cooperation among the Mediterranean countries, because these problems, the problems of flexibility, are the same all over the world, wherever the energy transition is in place. In the Mediterranean, the situation is complicated by the fact of the very limited integration of the systems for several reasons. The most important is that in many countries, the climate for investors is not good. They say the context is doesn't fit for investors, for market fragmentation, for the lack of long-term price signals, for the differences in the regulatory and legislative schemes that do not facilitate such investments. What we are seeing is that when countries try to develop decarbonization plans alone, these plans tend to slow down or fail because of this lack of interest of investors. That's why we are promoting the integration. That means developing the grid. That's the hardware, but it's not enough. It's also developing the software. That means technical rules for the interoperability of the systems, but also pushing to have a regional framework that connects with financial instruments that promote investments in the region. Going back to flexibility and the use of storage, in Italy, based on what I said before, the lack of appropriate signals from the market, it is in place. The government is launching a mechanism, an auction mechanism for long-term, the development of long-term contracts for developing storage facilities. Maybe in a second round I can give some details on how this mechanism works, because it's quite innovative. It splits the development of the storage facility by the operation of storage, with a trading platform where the market operators can buy slices of this storage capacity and use it on the market.
Yeah, a lot to talk about with wholesale and retail market structures to bring these resources to bear. We'll come back to that hopefully. Michiel, Angelo mentioned technology, and as a technology provider, what are you seeing? You also maybe hinted at grid codes as well. I know you have some thoughts on that. What are you seeing from your perspective in terms of technologies that may play to provide these grid services as we displace some of the traditional sources?
Good morning, everyone. So we all heard about the change in power grids today, and also the challenge with large integration of renewables. And integration of renewables, it is the critical step towards sustainable energy future. And when it comes to technology, we already today have a complete portfolio to meet the demands from the power grids, to meet the demands to have a secure power system operation. There are several technologies providing the same type of services, which means that we can do an optimization when it comes to technology providing fault current contribution, inertia, voltage support, and frequency control. We have developed already today, the technology is here today when it comes to grid forming devices, which means basically that converter-based solutions can provide the same type of service as rotating machines. There are a lot of installations globally. This also means that we can provide solutions with lower losses. This is fantastic. This also means that it's very, very important when we look for future products that the requirements are functionally. As a manufacturer, and also I think as a user, we don't want to see requirements that are stipulating one type of solution. We would like to see the requirements from the power system. And then we can basically optimize the solution, both when it comes to technical performance, but also to all different types of services that the technology can provide. Further, you mentioned grid codes, Daniel. We also encourage every country to revisit their grid codes and revisit requirements for interconnections. Because by doing that, we can make sure that we have a smooth integration of the renewables. This has been done in many countries, and I think one of the first countries, or the first countries, was in Europe. So basically in Germany, we have changed the grid code in 2 stages. First, we integrated the converter-based solutions with the grid-forming functionality, replacing the machines. And in the second stage, we also integrated the energy storage part. So basically, you can provide also inertia with the converter-based solutions. Finally, I also would like to highlight the importance of collaboration, partnerships. Since we have this transition all over the world today, the lead times are increasing. What we could get in maybe 18 months in the past will take 36 today. This is filling up the factories and also filling up the demands for all the manufacturers when it comes to resources. So it's highly encouraged to look for collaboration, partnerships, making sure that manufacturing slots can be secured with manufacturers. I think I stopped there.
Thanks, Mikhail. Appreciate you setting that up. Dr. Al-Rashidi,
Yes.
you're a researcher. What do you see are the gaps? What are we missing right now in terms of tools, processes, technologies? What are you looking at from a researcher standpoint in terms of flexibility needs to enable the grid of the future?
Thank you for having me. Actually, I see we are missing a lot of things. Okay. As a research institute, as you know, I mean, we are doing research. I mean, especially, I mean, as we are a governmental research institute. We are doing research to support the government in advisory, you know, energy and also other aspects. But mainly for energy, especially now since 15 years ago, we are building our capacity in research. And we started, I mean, that's before 10 years ago, by having the Shigai Renewable Energy Park, which, as you all know, it has three, I mean, variable renewable energy, CSP, PV, and wind. Having those operational and grid connected alongside, we have also, I mean, a big network of weather, I mean, stations. We managed to tackle a lot of research, I mean, projects, which we believe that it will help, I mean, whether the policymakers, the government, the grid operators. The first one, we thought at the beginning that it's crucial for any, I mean, region are going for high penetration of renewable energy, is to have an energy forecasting system, which we have done. In 2017, we started work collaboration with the NCAR, National Center for Atmospheric Research in Boulder. I'm sure EPRI also, they did a lot of work with them. So we have built, I mean, this, I mean, system because we have the power output coming from the Shigai, and we have the data coming from the measuring stations. So we managed to develop that system, which we are, in the next couple of months, we are inaugurating. Also, that required, I mean, to have a higher performance computer, which we have also, I mean, established there, you know, to do that. This, I mean, forecasting system is very, very valuable. Actually, it provides the grid operator with very, very precise, because the grid operators, they don't understand weather, and they don't want to know the forecasting of the weather, you know. They want to see the output coming from the renewable power plant and how it is, and the uncertainty it's coming with it, you know. So they can manage the flexibility. So as you can see, the output of this project, it can support the flexibility as well a lot. The second thing also we have focused to work on it actually is the research, the integration of renewable. We don't believe actually in, as I've heard a lot, I mean, in this forum, you know, about going solar, you know, I mean, a lot, you know, or we don't believe in that, you know. We believe is the best for our region, because we have a lot of resources of solar and wind. We believe is the best thing is actually the mix, the complementary of both technologies. But that depends on the region and the site where you're gonna use it. So we have investigated that, and we did a project also researching this, you know, whether it's a spatial variability, complementary, where you use actually one technology, but you, I mean, distribute it in a larger spatial area, or actually use both technologies, and also but with a certain mix, actually. That's require a lot of research. So, yeah, and you will be surprised, actually, from the outcomes of this research when you see, for example, going only solar, you know. And we are in a region, actually, looking for the technology that has the highest capacity credit. And solar has the worst capacity credit, actually, because it reaches a certain level when you have a high penetration of capacity, and then it's plateau, So whatever you do, you cannot go beyond that, But mix solar with wind, that reduce variability, smooth the output of and support the capacity credit,
So you sort of set up, our time gets away from us so quickly, but I want to have a conversation now.
Yeah.
Each of you talked about sort of a planning aspect to flexibility, right? There's all these many different potential sources of flexibility. There's needs for being able to assess the need for flexibility. So just sort of quick answers and maybe a little debate among you. Do we have the planning tools and processes that we need to most optimally select the sources of flexibility to actually build into our grids?
No, the problem is not the source of flexibility, if this is your question. I mean, there are many ways, actually, where you can actually resolve the flexibility. As mentioned by, our guest, the battery is a good solution, and many other. But first, you need to exactly see how you want to plan your, power system. Yeah. Are you gonna, are you gonna penetrate the renewable for capacity credit, for example? So the energy of the renewable you need it at the time, it should be maximized at the time you need it. Okay? Because at the end of the day, you need to look at the residual load. That's what you end up with. Okay?
Do we have the tools that are needed, though?
I don't believe we do. I genuinely don't believe we do have the tools today. I think we do have tools that can help, sure, but I think the scale of the problem we're facing, we simply don't have those tools. Like a good example, if you were to plan a 100%, 50% renewable system, you need to be able to look at, weather and what weather's been doing for the last 40, 50 years. The reason why you absolutely have to do that in today's world is because if you plan and you take a good weather year where you have a lot of good wind and a lot of good solar, and you take that as your basis for your investment for the next 40 years, you get to a point where what if next year doesn't have the same resource of weather for the year you planned against? So you need to look at a whole lot more years, and secondly, you need to look at the granularity of that as well. For a gas station or a coal station in Australia, all you have to do to know what that plant will do is to sign a contract with a gas producer or a coal producer. You have your inventory, and you can control the output for as long as you need based on the commercial contract you've signed with the fuel producer. But you can't sign a contract with the sun, and you can't sign a contract with wind. So you need to be able to understand how this is really going to affect you, and to do that, you need to be able to look at lots of data on weather for a long time.
And the fact that climate is changing means the historical may not represent
Correct.
the future, right?
Correct. Yeah.
Carlos, I know you were trying to get a point in.
Yes, thank you. I'm trying to turn around a little bit your question. You're asking, do we have the planning tools? I think we have the planning tools that we have for the systems that we have. Some of them are brand new, others are in a transition. We know what's going to happen reasonably well. Solar resource is gloriously predictable in this part of the world. Wind, even if it's less predictable or more difficult to predict in the longer range, however, it's relatively small. I would take the question to a different level. Do we have not just the tools, but actually the incentives to make these, when we go deep into the future, to the deep decarbonization, deep electrification of the systems, of the economy, do we have, and I'll leave three things here for the discussion, do we really have what it takes to provide the flexibility and everything that comes with the deep decarbonization of our systems, where we are deep into, in the 2030s, 2040s, 2045? Today we run single buyer models here in the region, which actually mean that we have an implicit carbon price and we have implicit ancillary services costs, which reflect in the total cost of the system at the end of the day. We don't seem to need, at the moment at least, a carbon price because we can mandate the energy mix, and because, like Bruce was saying, the most cost competitive option is also carbon free. When we go deep into the future, we might need CCUS, additional nuclear, expensive batteries, other things which will cost more than the business as usual. The implicit carbon price that I was talking about will surface. Same for the ancillary services. Do we need to move from that system to one that makes the prices and costs explicit? Do we need, in the future, ancillary services markets as such with provide price signals for investors? Do we need carbon price? Food for thought. Secondly, do we need to adapt those price signals in the form of tariffs that incentivize not only supply side but demand side solutions? Because at the moment, there is little incentives to change your consumption pattern. You just pay a flat rate, in many cases subsidized, which doesn't recognize any of the costs that I was talking about. Therefore, as a consumer, large or small, your incentive is small to adapt. Do we need to also adapt the tariffs to provide those signals for the rational behavior? And that is the second, item for, what it looks to me more like an economic discussion. I'm an economist, and that's where I feel more comfortable. And thirdly, do we have the size of the markets that we need? Is deep decarbonization, as I was talking about, going to be cost-effective and efficient in relatively small fragmented markets, or should we actually aim at a larger integration at the GCC, like we have in other parts of the world where the larger systems can provide cost-competitive flexibility, cost-competitive base load, that is actually traded across the border, because there is a way where you can find the efficiencies and where you can actually find the capability to meet your very demanding targets with the support of a larger market. Yeah. These three things, I think we need to carefully discuss in the region. We're not there yet, but the clock is ticking, and we need to have these type of discussions, I think, very many times ahead of making any decisions.
So Carlos, you think the markets and regulatory structures are just critical to ensure that we get the incentives to bring those to bear?
I was trying to say, what we have today, we can manage. But where we're going, it will be ever more challenging as we go down the road.
Gotcha. Mikhail, you got a comment?
Yes, I would like to add that when it comes to tools and models, I think the OEMs, the manufacturers, has the competence. However, we are having so fast development, so we are a little bit behind when it comes to guidelines and models in trade associations. So I think we need to catch up here, making sure that also the users will get the competence.
So thank you for already putting in questions. We got a lot of questions coming in. We're not going to get to our 1 minute each wrap up because we're already under 1 minute each to finish this thing up. So we're just going to keep having the conversation. So one of the questions that came in that I'll throw at you quickly is, how do we replace sort of the traditional gas-fired primary reserve system with synchronous rotating machines with a lot of inertia to a highly inverter-based resource type of grid? From a flexibility standpoint, not just the variability and the uncertainty, but also the actual stability of the grid. What do we need to do to ensure, what are we missing from a flexibility standpoint to have that coming into the grid? What resources or capabilities do we need? Go ahead.
I'll pick that up. I mean, the batteries that we're procuring at the moment to replace this rotating mass that's the gas generation has provided historically is simply to go for grid-forming inverters as a specified requirement from these batteries. So the 400 megawatts of reserve-providing batteries that we are procuring will have grid-forming inverters. It's become the standard. 3 years ago, it was very hard to buy inverters which were grid-forming. Now it's become the norm, and the cost premium associated with that is tiny. If I may, make one question around the technology. Yeah. Do we have the systems? I think the question is, are we prepared to pay more by not being able to optimize? What Lumi was talking about is, do we build additional storage to guarantee the 2 or 3 days when perhaps we get dust storms once every 20 years or 30 years? In other words, how much extra are we prepared to pay to safeguard our system? And ultimately, I think that's the question. Yeah. How much more are we prepared to pay to have that security?
And that's really a planning criteria question, right?
Yes.
What's our criteria that we're going to actually build to as we go forward?
Yes.
So we talked about planning, we talked about markets. From the operation side, we didn't get a lot there. Do we have the operational systems in place in order to leverage the flexibility resources that we're moving towards? When we think about trying to leverage more of the demand side, and that came up several times, do our control systems allow us from a markets, from a transmission, distribution, and even to the customer side to interact together to be able to deploy that resource as we come forward? Or are there other operational needs?
I think our ex-octopus person should speak here.
Yeah, I'll speak from two sides. One from back in when I was in the investment world. You need innovation in this area. Like, we are not going to run away from that. And I think there's something else we're not really discussing, which is the single technology dependency. So if the whole world is going to net zero and we're all looking at batteries, lithium ion only comes from certain regions in the world. So if you have, we did some analysis recently and we saw that if you had a flood in Chile, like we've seen in the past, there could be a real serious supply crunch if the demand for lithium ion continues on the current trajectory. That's one. Secondly, we need to have other long-duration energy storage sources that are not really dependent on rare earth materials, right? And I think to do that, the customer has to come into play here. But how do you now fully integrate a customer into your control room in a way which, you know, demand is moving now and supply is also moving with weather? I think innovation is really the key that we need to look at here.
Anybody want to follow up on that? Offer anything else operationally? Angelo?
Well, let's say that with the current technologies, we see only two tools capable to provide the services is pumping hydro and batteries. Yeah. And referring to technologies, lithium-ion is the only technology that guarantees now the achievement, necessary achievements. What is important is that in terms of policy, we are not conditioned by technology. We should be technology neutral as much as possible, so guarantee the perspective to develop flexibility tools independently on the state-of-the-art technology. But for the time being, I don't see other sources of flexibility suitable enough to provide the requested services other than pumping hydro and lithium-ion batteries.
Got it. We've got 2 minutes. 20, 30 seconds, just each of you coming down the row. Start with you, Dr. Al-Rashidi, give you just a second. If there was one new capability, process, market capability, technology to enable flexibility, what do you think the number one priority that we should be together collaboratively thinking how we should overcome to ensure we have the flexibility needed going forward? Just quick hit. What do you think? Biggest need?
Yeah, the problem is not, I see it, it's not with the flexibility. The flexibility, it's available, the technology is available, you know, whether it's fast or whatever kind of flexibility. The problem I see it now with the market trend actually is actually the planning of the renewable energy, deployment. That's what I see it, in the Gulf. Because that will cost later on, more flexibility if you go, for example, for solar.
So improved planning. That would
yes.
be, Mikhail.
For me, the flexibility comes with functional requirements. Make sure that we have functional requirements, then we can do optimization and come out with maybe not the higher cost, like Bruce said. We can do more with one technology.
Great, thank you. Angelo. Angelo, yeah. Biggest need from a flexibility standpoint? Just quick hit. What if one thing if you could put into place? I'll come back to you. Back to you. Lumi.
For me, I think we need to create a bridge between planning and operations.
Okay, yeah. A lot has to happen in that regard. Very good. Bruce?
This is an incremental process. We're not going to solve it overnight. We're effectively trying to build a jumbo jet from the scrapyard, trying to work out what to do next. So we have a system today, unlike NEOM, and we are trying to transition. So, he's trying to bolt the wings on, we're trying to change the engines mid-flight. So it's an incremental process for us, and I think, I would second the comment that the bridge between planning and operations needs to be very strong.
Yeah. Carlos?
3 things. Technology, we need more technology. Clean technology, storage technology, carbon emission removal technology, we need that. Secondly, we need price incentives or clear price signals. And we need processes like system operators that can cope with these three things together.
Oh, very good. Yeah, clean, firm technologies, market transformation, and
institutions.
integration. Yeah, very good. And Angela, wrap us up.
I have my answer now.
Okay, yeah.
Well, let's say supportive mechanisms, because we, at the planning level, we have what the TSO can evaluate in terms of requirements of the systems in parallel with the development of renewables. We see that the market sometimes doesn't provide the right signals, so we need the supporting schemes that, if, at least talking about Europe, where we have policy targets that are the key drivers of the transition, we must have supporting schemes that are capable to align the appetite of investors with the policy targets.
Perfect. There were so many questions that you all sent that we didn't get a chance to address. I apologize. And other questions that we had talked about that we wanted to discuss. I appreciate the interaction on the topics we did get to touch. Please give the panel a round of applause. Thank you all.
Thank you, Mr. Daniel Brooks, Vice President of EBRI, for this session. We would like to invite His Excellency Dr. Naif Mohammed Al-Abbadi, GCCIA board member, to honor the speakers and to take a group picture. Mr. Daniel Brooks, Senior Vice President of EBRI. Carlos Gasco Travazedo, Executive Director, Department of Energy, Abu Dhabi. Engineer Bruce Smith, Director, Planning, EWAC. Dr. Lumi Adisa, Director, Energy Systems, NEOM. Mr. Angelo Fernetti, Med TSO Secretary General. Mr. Mikhail Halonen, Application Engineering Manager for Grid and Power Quality Solutions and Services, Hitachi Energy. Dr. Majid Al-Rashidi, Research Scientist, Kuwait Institute for Scientific Research, Kuwait. Group photo. Let's take a group photo. Thank you, Your Excellency, Dr. Naif Al-Abbadi. Thank you again for everyone. Thank you, Mr. Daniel. Thank you. Moving on to technology highlight from Amexon.
Your Excellencies, distinguished guests, it's my honor to be here with you today. 1 year ago, we as Amexon were by your side right here in this location to officially launch the electrical interconnection extension project between GCCIA countries and Iraq. I will say a few words about these projects later in my speech. This year, and thank you for the opportunity, I'm here together with my colleagues from Vinci Energies in the Middle East to give you some insights about our commitments but also about our actions regarding net zero. As brand director of Omexom, which is the energy infrastructure brand of Vinci Energies, I look forward to sharing with you how Vinci, as a global operating group, is a strong contributor to achieving net zero in the construction, concession, the real estate, and especially in the energy business, where we operate towards two major transitions: the energy transition and the digital transformation. The energy transition is an absolute necessity, we all know that, and renewable energies and other low-carbon energy sources are on the rise to ultimately replace fossil fuels as an energy source. To limit global warming, we need to decarbonize by massively electrifying all energy-depending sectors, entire economies. Electrical energy demand is therefore going to be colossal in the years and decades to come, even if we do not understand yet the full extent of it. If you break down the technical and economic challenges facing the energy transition, we clearly see an economic-wide approach to decarbonize, which will, among others, lead to an extensive modernization of energy infrastructure. Exactly at this point, we, as Omexom, come into play. As a global player in this field across 39 countries, including Middle East, and with a turnover of more than $5.5 billion. We assume environmental responsibility. We have committed to reducing our own direct greenhouse gas emissions by at least 40% by 2030, comparing to 2018. We also aim to reduce indirect greenhouse gas emission, our Scope 3, by 20% compared to 2019 levels. But as I said before, it's not only about commitments, it's about the doing. The question is how. And I would like to start with innovation. Innovation is key. I think we all understand this. It's true that many solutions still need to be redefined or scaled up, but we have a strong foundation. For example, this is now a real insight, Vinci International Innovation and Environment Challenge 2024, that's an internal challenge in our group, gathered nearly 1,000 initiatives from business units across our activities. This shows the level of commitment and creativity within our teams. I've spoken about direct greenhouse gas emissions, Scope 1 and 2, which we can directly influence and take action to achieve decarbonization. This includes how we heat or cool our offices, warehouses, workplaces, how we convert our fleets to electric vehicles, including electrically powered trucks and specialized equipment such as excavators. We have the decisive advantage that we have a very large presence in the Nordic countries, such as Sweden and Norway. And we know that the topic of e-mobility is already very advanced there. And as far as we can see today, it works quite well. We also focus on CO2 neutral carbon construction sites. And we are currently testing various, essentially self-developed solutions for solar power generation and battery storage to replace heavy diesel generators where there is no electricity available connection. Let's move on to the indirect greenhouse gas emissions, Scope 3, where it becomes particularly complex and challenging. And let's have a look at our solutions, experience, and projects. For us, it is crucial to get a holistic understanding. We want and we need to understand the carbon footprint of each of our projects. For this, we use own tools based on data that is as realistic as possible. And with the right understanding of which process and components significantly contribute to the CO2 footprint of each project, we can identify, develop, and offer alternative solutions. At Vinci, we are aware that as a very large construction company, we are part of the problem. But we also want to be pioneers in solving the problem. So a first great and forward-looking example is the topic of low-carbon concrete. Globally, concrete production is responsible for 5% of greenhouse gas emission. That's a lot. Our formulations can reduce up to 70% of CO2 emission compared to traditional concrete. We have already started to implement these internal Vinci solutions to our energy infrastructure project. For many other materials and equipments that we need to purchase for our project, such as steel, cables, switchgears, transformers, we, as an independent integrator of solutions, apply this approach to package offers that not only meet the technical requirements, but also have positive impact on environment. Sustainability regarding net zero can also include measures to significantly extend the overall lifespan of structures or relevant market-scarce components. For example, we have a factory in Finland where we completely refurbish large transformers. Let's move on to another relevant topic in our point of view. Worldwide, we use SF6 gas in GIS systems, knowing that, unfortunately, SF6 accumulates in the atmosphere and is 23,000 times more harmful to the climate than CO2. Therefore, a significant contribution to net zero is to replace SF6 in GIS systems with alternative solutions. For instance, in Scotland, Omexom has completed a 400 kV Kintore substation project for our customer SSEN, which is, as far as I know, the world's first 400 kV green gas for grid solution, and in this case, it was G3 from GE. Comparatively, this gas has more than 99% less global warming potential. That's an important milestone on the path to net zero. Seen more from a macroscopic perspective, more and more countries drive towards net zero, which is excellent. But it also represents huge challenges, as we all know. Connecting the new decentralized clean energy power plants, transporting electricity over long distances and across borders, integration of power into the systems, dealing with intermittency, and ensuring a balance between production and consumption. Let me give you a few examples of how we contribute to mastering these enormous challenges today with our customers and partners, like, for instance, Hitachi Energies. Knowing that nuclear technology contributes more indirectly to net zero, but becomes more popular again, I would like to mention that we are active in the nuclear sector, especially in France. Also, because we are convinced that nuclear energy plants play a significant role in achieving net zero. There is also the rediscovery of other traditional technologies, and their expedient use also makes sense in many places, perhaps to relativize the problem of intermittency. This can be the use of phase shifters to control current flows more flexibly. It can be a synchronous condenser, we heard about that, which helps to manage the variability. Already? Okay, sorry. So thank you for your attention.
Thank you, Omexom, for the technology highlight. We will move on to panel number 5. Our next panel explores strategies for designing and operating a net zero grid. Discuss critical topics such as integrating renewable energy resources, optimizing grid flexibility, and implementing advanced technology, including potential role of AI. Ladies and gentlemen, welcome to the stage our moderator for this session, Dr. Adrian Tui, Director at EPRI. Joining him are the speakers, the esteemed panelist, Engineer Ahmed Zahrani, Vice President of Operation and Control, Saudi Electricity Company. Dr. Yusuf Al-Abdallah, Research Scientist, Kuwait Institute for Scientific Research, Kuwait. Engineer Aisha Al-Muhammadi, Head of Transmission Network Planning, Kahrama. Mr. Umar Al-Amiri, Operations EWEC, Abu Dhabi. Mr. Muayyad Al-Kadhim, Manager at Network Planning, GCC IA. Welcome everyone on stage.
Thank you. Can you hear me okay? Is the mic's on? Okay. Thank you all. Good morning, everyone. Thank you for joining this session. So the next session here today, we'll dive deeper into the topics that we've kind of explored a lot, particularly in the previous session, but even yesterday as we talked about some of the policies and some of the mechanisms to reduce carbon emissions and interconnect the systems. Certainly I think Lumi from NEOM said it really well in the panel just gone. We're going to need to see a bridge between planning and operations. I think that articulates it well, as Lumi often does. As we think about the transition to net zero, we will require the integration of renewable energy resources, optimization of grid infrastructure, really thinking about reliability, flexibility, resilience on the system. So this session is going to dive a little bit deeper to explore some of the operations and planning impacts. We're fortunate to have both operators, planners and researchers on the panel so that we can kind of explore this topic from a few different angles and think through how you both plan the system and make sure you're handing off a system that actually operates and is operable, and then that feedback loop from the operators around how they can better plan the system and back to the planners to be able to enable some of this net zero transition. We'll need to think about some of the new infrastructure to support the future grid, as well as making best use of the grid we have, understand some of those flexibility needs, and then get out into things like control room and the operational tools that will be needed in the next decades to be able to decarbonize the system. Of course, all of this comes in the context of the policy and market challenges that we'll see there. So again, the focus is here around the technologies, the tools, the methods, as well as the workforce to actually enable the technologies that will be deployed. We need to think about those different potential futures. We look 20 years into the future, 30 years, as we're starting to have to do now, and think about what are the different scenarios and how they may play out and what that means for operating the grid. So what I'm going to do first is ask each speaker to just take 3 or 4 minutes to introduce yourselves, your role, and what you're seeing as some of the key challenges, whether it's operating the system or planning the system. And so maybe, Engineer Ahmed, we'll start with you and some of the challenges that you're facing in Saudi Electric system as you operate that system.
Yeah, thank you. Assalamu alaikum wa rahmatullahi wa barakatuh. Good morning, all. First of all, it is my pleasure to participate in this session in order to share my thoughts, insights, and the key challenges and the integrated solution in order to overcome the issues and to achieve the net zero grid, either from the planning perspective and the operation perspective. I have a 20 years experience in the power sector. It's back and forth between planning and the operation in the last 20 years. So I have seen the different issues, different key challenges from the planning perspective and from also operation perspective. So I will start by the Saudi Electricity Company announced its ambition plan to achieve the net zero target by 2050, which is aligned with the Kingdom vision. So the first key issues or key challenges is the availability of the renewable energy integration and how can we build and upgrade our existing structure in order to achieve that target. So whenever now we are building or planning the renewable energy integration, we have to keep in our mind that we are not, setting the infrastructure or building the new construction in order to achieve the 2030 vision, but also it should be flexible infrastructure to absorb and accommodate any change or any variable in the next 30 to 40 years. So this kind of mindset should be changed in order to predict and forecast what is the new challenges in the system operation. The second point of the renewable energy integrations, we have now almost 88 to 9% of the renewable energy already integrated to the Kingdom of network. And we are expecting to have an annual basis from 15 to 20 gigawatts forward up to 2030, so that it's need an agile system operation mechanism, system operation policy and procedure, and also a close coordination between the planning sector and the operation sectors, because that's a close loop between the issues from the operation and the planning should be shared, should be the close feedback, and also the integrator with the ecosystem. Agile mechanism, agile regulation, and also updating the grid code by adding the requirement of the renewable energy. Also listen to the operation, challenges, share that challenges in order to overcome this kind of issue. The second point, it is integrated of the battery storage. Currently, we have 9 projects under execution with 4.5 gigawatt, and it is expected to be in service within the 2 years. And we are expecting to achieve 10 or 12 gigawatt within the coming years. So these kind of different systems, and it will add a complexity to the system. And these different systems should be integrated in well in order to help the system operator, which is, deal with the real operation, in order to mitigate any risk, because we'll have and we'll face a different system at the same time. We have a real-time operation, we have a renewable energy integration, we have battery storage, we need to expand our cross-border exchange and also the interconnection between the different regions. All of these in new technology, we have it's integrated in the SCADA system or protection system. We have different systems like WOMS. So the system operator should be available with the different tools and technology in order to mitigate, monitor, measure, and mitigate and take an action. And I think I strongly believe that it is an era of the data. We have a valuable data. What I believe we didn't utilize it up to now. So these different data from different systems should be integrated in one pool in order to give the flexibility and also the resilience of the system and the top of everything on the objective. So this is my first remarks.
Thanks, Engineer. I think that sets up a lot of the discussion here, a lot of interesting thoughts around the need for kind of thinking ahead and bringing some of those operational issues into the planning context.
Yes.
And large numbers there around the amount of solar that you're going to be installing, a battery that you're going to be installing. So
yes,
how you're going to have to keep operating on an hour-by-hour basis and keeping reliability is going to be really
definitely
interesting there. Dr. Youssef, from a research side, what are the types of things you're looking at? What are the key challenges you see? Maybe you could talk about some of the work you're doing in this space.
Thank you, Aidan. Assalamu alaikum. Thank you for having me here today. So as a researcher, I've had the opportunity to work on several of these types of integrated resource planning problems. And this goes from looking at, for example, at a certain space, when we're looking at, for example, what Dr. Majid did with Shagaya Renewable Energy Plant, we were looking specifically at how can we maximize the energy yield out of Shagaya. And that gives us one, when we're looking at that and we're building these optimization models, we see one answer, and it says, oh, build a lot of solar PV, and this comes with a lot of variability. So then when we take it to the system level, this variability, and we build out the optimization model on the system level, well, the choice is no longer just solar PV. It wants solar PV and storage, and it wants diversity in terms of wind. So all of these planning models, it all depends on the subset of the problem that you're looking at. And then, if I could go further, if you're looking at the nexus of energy and water, well, in all actuality, what happens, Aidan, is that what's left over is that the Gulf states, especially the smaller ones, are going to need some firm capacity because they need desalination for MSF and MED desalination. These thermal desalination technologies, yes, you could serve some of that with solar thermal, but not at that industrial scale where millions and millions of imperial gallons are need to meet the populace's needs. That growing population of course, yes, you need electricity, but you also you'll also need water. So and yes, all of this needs to be driven by data, access to data, and a planner can only go so far. And you know, when it comes to these renewables, when we're planning for renewables, what we could do is we could say, okay, we're likely to get this this energy throughout the year. We're likely to get them in these hours, but nobody, no planner can say we're gonna in 2028 we're gonna get 10 gigawatts of solar PV and at 3 p.m. We just there's no way we can guarantee that. So what we have to do in our optimization models as well is we have to build in that gap where we identify the operational flexibility that is needed due to these higher penetrations of renewable.
Thanks, Dr. Youssef. Yeah, that area of kind of integrated planning and optimization is definitely something near and dear to myself and a lot of the work we do at EPRI, but I think something we should try and explore further here in this panel. It's going to be really important to be able to do that and bring some of these issues into kind of a planning framework. So, thanks. Engineer Aisha, from a Karama perspective, maybe you could talk a little bit about some of the challenges you all face and what your role in that is.
Thank you, Aidan, for the question. Good morning, everyone. It's actually a pleasure to be here today to discuss this important and timely topic of Qatar's journey towards achieving net zero. As we all know that the world now is facing a dual challenge of the continuous increasing demand on energy, as well as the pressing threat of climate change. So, of course, Qatar is one of the countries that are stepping up in this as a responsible and forward-looking nation. Basically, Kahrama, working as part of Kahrama, which is the sole operator for transmission and distribution in Qatar, we have both the unique opportunities as well as different or several challenges that we are facing. First of all is integrating renewable energy is increasing the variability of power. So we are having a continuous demand that cannot be supplied during the time where renewable is not there. So as you know, renewables, or what we have in Qatar, is the PV. So it's very sensitive to daylight and weather conditions. With any fluctuations in the weather, or when the solar is off, we have the challenges of supplying those demands. Secondly, the more we integrate renewable energy, the lower we expect our system inertia as, which means that the stability of our grid is also facing some challenges. Of course, there are solutions to this. For example, STATCOM devices, and Kahrama is already looking into these devices and in the process of implementing STATCOM into the system. Moreover, I believe that the planning or the expansion of the grid itself needs to be assessed in a different way, especially that forecast is getting more uncertain, especially that you cannot predict the productivity of the solar and the weather forecast. So this is another challenge. Lastly, I would say that the grid code that we have for our system was basically established for our traditional generators. So when we're talking about integrating power system, it means that the grid code needs to be modified to address the characteristics of renewable energy to ensure the power stability and quality. And Kahrama already took the lead in this, and we have established a committee which is currently looking into the grid code modifications that need to be done in terms of ensuring reliable and secure power supply.
Thank you, Engineer Aisha. Yeah, so a lot of echoes of the previous panel, actually, with some of the discussion around grid codes and inertia and some of those types of topics. And And then the interesting thing there about both T and D responsibilities under you, I think we can maybe come back to that and talk about how that's going to change your planning processes. Omar, from an operations perspective, we heard already from Bruce about some of the things that he's planning for and what you're seeing coming in. What are the things you're thinking about when you hear and you see his plans and talk to him about the kinds of needs you have? So maybe you could talk a bit about the challenges at EWEC and the operations side.
Assalamu alaikum, good morning. So as I'm heading the team of operation within EWEC, the system operator, there were targets that started since 2017 where we were switching from normal thermal plants to nuclear plants, and renewable also plants are being integrated to the system, where we had 100% was in thermal, and now I think we're having around 40% of energy served through clean energy sources. That transition was not, of course, easy because it was something new to the grid operators that they are not used to. We had to change our operational philosophies, we have to update our procedures, and also we had to train the engineers in the control room to be ready for these challenges. Through these years, we have faced maybe something here in the region that people should be aware of, is that in the summer, our demand is totally different than the winter. And we used to build our capacity for the summer. Now we're seeing that even the winter is more challenging than summer to control the grid. So as EWEC, we started investing in flexibility in the current existing plans and also whatever solutions that we can do to the grid and give control or automation to the grid operators so that they take quick decisions, correct and decisive decisions to support them make the right decisions. And this flexibility actually enabled to have more penetration from renewable in winter, where we are proud to say that we have reached, for example, 1 hour, 80% of the system under EWEC was the demand was served through clean energy sources, and that was maintained for 2 years. Now, as mentioned by Bruce, the target is going 57% in 2030, and then 2035 we're going to 65% and going to net zero in 2050. I think the previous panel touched on a very important point, that the close coordination between operation and planning is very important and crucial to solve these challenges. Luckily, at least in EWEC, we're having the single buyer and system operator under one umbrella. So actually, since we were merged with under EWEC, we have seen better coordination, and all the operational requirements were actually being part of the new projects. The intermittency of renewable was the challenge, I would say, especially because we brought a 1.5 gigawatt solar plants, PV2. However, we cater for that by introducing new technologies, like active control, fully automated in the control room, reactive control, participating in reserve requirement, tertiary and secondary, that's coming from PV2. It was a very successful experience, and they actually made our life in control room much easier, these technologies, especially in winter, because you have less committed thermal generation as for now.
Thank you, Omar, and definitely bringing up some really interesting challenges. The shift in when the challenges happen is something we see across the world. It's no longer can you get through your peak day and then everything else is okay. It now is, different times of the year, different conditions really are the things that are challenging. But that challenges some of the reliability and resilience, and Maya, the GCCIA interconnection can potentially support a lot of those challenges and help mitigate some of those through some of the increased interconnections. Maybe you could talk a bit about the role you have, some of the planning activities that are going on there.
Okay. Assalamu alaikum. Good morning, everyone. First, it's good to mention that GCCIA is a system owner and operator, transmission system operator and operator. So we do not own or control the generation side. One of the major, let's say, aspect we are looking at through an agreed process is to look into the adequacy of the system up to 10 years ahead. And one of the challenges we see with the renewables, there is benefit when it comes to combining the whole system. But at the same time, finding the value of renewables into the firm capacity is somehow challenging. Luckily, we have the basis method to calculate those values. I mean, it's not that difficult. But then implementing those into the modeling, it might be a little bit challenging. So for example, we usually look 5 years plus ahead. Predicting the weather 1 year ahead, that is already challenging. Now predicting it 5 years ahead and more, that is even more challenging and more complex. Given that we use historical information, historical data with weather to come up with those renewable profiles. But again, we do see values of combining the system. Yeah, we see the improvement of the capacity into the firm capacity, into the adequacy. One of the key questions we are looking at now, and we don't have a solid answer for it, is if we should consider the flexibility reserve. We've heard a lot about it. If we should consider it in the adequacy side. There are two different domains in a way, but the classical adequacy calculation usually covers the deterministic aspect of the operating reserves. But combining now the flexibility requirement, we are entering more into statistical and probabilistic calculation. That's not to say we will have a problem, it's just that we need to make sure that we don't have a problem. So for example, flexibility, I mean, you could say it will happen mostly during winter, during clouding, for example. At that time, we have a lot of reserves because the demand profile is like 40–50% lower than the peak demand. But are we okay in the summer? That question we are trying to address at this time. Another benefit, of course, is we've just heard that the inertia. Luckily, we are combining the system inertia between at least 5 countries in the 50 Hz side. Unfortunately, for the 60 Hz side here in KSA, there is no, let's say, direct support between the inertia. However, GCCI and GCCIA, we have the HVDC connecting both systems, and actually we do see benefit from the HVDC contributing into the frequency support. So in a way, it is providing some kind of synthetic inertia. I think that's the right term. It's not an actual inertia, but more of synthetic inertia. So it is something we are seeing and in real operation. Even with renewables, we had seen it. We have experienced it as well.
Thank you, Mayed. Yeah, so a lot of, across the panel, I think a lot of my favorite words have been said here: inertia and adequacy, flexibility, integrated planning. So we could obviously spend the rest of the time taking any one of those and just dig deep into that, but maybe rather than trying to force it into one particular topic, I might just ask and allow any of you to speak up, but Engineer Ahmed, maybe we start with you. In terms of the tools you need, whether it's operating tools or planning tools, going back to the last panel as well, what are the kind of advanced tools that you see are still in need or still under development, and we need to understand whether that's artificial intelligence and the use of that, or whether it's better modeling approaches, inverter functionality? Is there particular things that you think are really missing and needed to support the future?
Okay, one of the tools I think it is crucial to have it in the near future to expand and maximize the real-time digital simulation in order to ensure the modeling and the testing of these kind of the new technology from the inverter basis. So these kind of the RTDS, what we call RTDS, need to be expanded, leveraged more, and also engage the people from the planning and the system operation in order to understand what is the behavior of this kind of the technology and what is also the risk behind it. And also the second point, it is, exploring the new options of the demand side management. Actually, we last year in Saudi Arabia, we did a pilot project in order to test the flavor of the demand side management for a customer that connected to the transmission level. And it was attractive for the customer to join, and they are looking they are go after us in order to participate in that pilot project. So building a clear mechanism, either financially or operating mechanism, in order to deploy the, for example, the demand side management, it will be added a value to be a flexible and for the operation, and it is a strong tools in order to utilize it. The third items I can see it is the updating the policy and procedures. I'm talking the policy from planning and the operation perspective. Now different, as I mentioned, different systems are integrated, different systems are utilized in order to monitor and measure the grid performance, but we didn't come up with the integrated solution in order to help the system operator to take an action and also anticipate what is the contingency. For example, let's take it, I can see in the future maybe the AI can participate in taking an action, not only from the system operator. After he did all the analysis and gathering the data from different systems, he can take an action to help in order the system, because as much as we add new technology, the complexity of the system, it will be more and higher. So we have to, explore all the options, all the new technology in order to help us to maintain the security of the supply, because there is no, allowed tolerance in that direction. You have to keep the system security of the supply in the top of everything. And also one of the main challenges I can see, it is as long as we moving in the transition stage. Now we are moving from the, conventional power plants, renewable, till the first milestone in the 2030, there is a transition stage. So how will you balance the system needs and deployment, the new project under execution? That during that transition it will be a lot of risk, a lot of issues. The system operation should be, equipped with the required tools in order to making and maintaining the security of supply 100%.
Thank you, Engineer Ahmed. And the Slido is open as well if folks want to ask questions. So maybe Dr. Yusuf, you could talk a little bit about some of the tools as well that you see, or the techniques that are going to be needed in the next few years, and what are the things coming down the pipeline from a research perspective?
What's coming in the pipeline in terms of research is that our optimization models, these planning tools, there's many planning tools. You can keep building them out more and more. You'll enable them with high performance computing. But really what's going to enable us to be able to accommodate this variability and this uncertainty from a planning stage really is to start to build out more and more transmission markets to accommodate the imbalances in all the different systems. So when there's imbalances in, for example, Qatar, then another country could provide energy, say the Emirates, and so really this forum and this organization, GCCIA, could be the catalyst to help bring about more renewables and also mitigate this uncertainty, because the wider geographic area that you go through, that you have, you're able to accommodate those imbalances, and you have more access to more resources. There's much, and with the expansion out eastward towards Jordan and Egypt, I believe. This would also help, because then you get a shift in time zone when the loads are different as well, and really bringing together the different operators with their issues and bringing the research on board to understand what their needs are. This type of communication is needed, and really these tools, the tools that they will come, but it has to be updated on a continuous basis. You have to repeat these studies. You have to, and the tools will only get better as you know what the needs of each operator are and what they're experiencing.
Yeah, nice to see you. So, Engineer Aisha, are you seeing something similar in that need for the tools to be updated on a continuous basis? Any specific techniques that you think are most important when we think about the energy transition?
Yeah, I think we're all in the same position in terms of the required tools. And as I explained earlier or talked earlier about the challenges, I think talking about the uncertainties in the forecast, I think there should be algorithm to do a better forecasting just in order to reduce the gap between the demand and the supply of the renewables.
Thank you. Omar, I know you all have been looking at things like AI and some of those advanced techniques. Is there particular things you're most interested in and that you find most promising when you look at that future techniques and tools that are going to be needed on the system?
Okay, so for tools, we have invested a lot in switching from offline tools that was supporting control room to online tools that the operators are using, like the generation management system and energy management system. This helped the operators to cater for the dynamic change that happened in the system, especially with the intermittency of renewable. They make now quick decision. They do studies online. They have indications for them. Regarding AI, how to utilize that, we are now in the process of utilizing the energy management system where data processing is there through the AI, maybe to give the operator some indication or recommendation to solve some issues in the grid, like if there is a voltage issue local or maybe a region-wise, what are the priority? What are the, like, do you have to go with the plants first? Do you have to go with a reactor or a capacitor if required? So all that merit, not just for generation, even for voltage control is already in place. We're also exploring a dynamic system assessment tool where in the future this tool will be available for the control engineers to have a 5 to 15 minutes granularity where it has a look ahead and give decision for the or you can say a recommendation for control room. Maybe if there is something happening in the network, what is the impact? Maybe there is no immediate impact, but with the intermittency of renewable and fluctuation, there could be a challenge in 4 hours, 5 hours. So that's something already we are exploring, and we have some development already done. Of course, maybe having AI supporting the demand side management, how the information will be presented to the control room, and maybe through an aggregator or through direct communication with the customers. Utilizing the WAMs and BMUs data that's coming from the site and give indication for the control room. I think this is where the AI definitely will play a role there to support the control room.
Thanks, Omar. And so it definitely seems like a theme of using that data we have better, understanding the way the system's going, providing operators more insightful actions that they can actually take. So, Moed, from a planning perspective, especially looking at the kind of wider area, are there particular technologies that you think are going to be the most challenging to plan for or offer the most promise in terms of the things we can do with them to support the future needs?
I think probably the most difficult part is the modeling aspect into the planning side, especially with the technology we are talking today. Somehow we are already behind with the current technology. It's not well proven in terms of modeling. I mean, it is there, but it might be difficult from let's say from vendor to vendor. So now doing it again ahead of time for what is the technology 5 years ahead, 10 years ahead, 20 years ahead, that's a bit challenging, I mean, in that aspect.
Thanks, Moed. Yes, so certainly the model development, and I'm sure others see that as well. Looking at the Slido, I think one of the interesting questions here, maybe it's a broader question, and I'd be open to whoever wants to take it first, but we think about reliability and we also think about resilience, and obviously there's overlap across those two, and I know some of the work that Moed, we talk on a frequent basis about some of these topics. What is reliability, what is resilience, and how do we come up with some of those? Have you all been thinking about some of those issues, particularly the resilience issue, you know, these extreme events? What are you doing to plan for those? And I don't know, Engineer Ahmed.
I think there is a clear boundary between the reliability and resilience. When you talk about the reliability, we'll talk about the approved criteria approved by the regulator. But when you talk about the resilience, it's a wide subjects. It is your ability to restore back and to contain any issues or incidents occurred in the system, and your ability to recover and go back to the normal situation with the shortened time. So investing in a different contingency or different severe incidents during the planning stage up to some level, it will be added value in order to mitigate this kind of the severe contingency, and also invest more in the emergency equipment and the emergency mobile, and also the increase your workforce capability and ability to mitigate and anticipate these kind of issues in terms of the resilience from the control center and the field operator, either the maintenance or protection or from generation side and distribution. So an alignment between these different stakeholders inside the utilities, and increase and develop these kind of the emergency plans in order to detect any issues, and also act in a fast manner in order to restore the power to the customer. The second point I would like just to mention that we can leverage the utilization of the smart meter, because still the majority of our planning is starting from the top down. We didn't utilize much the smart meters that's connected to the customer with the measurement, with the analysis, in order to detect the load pattern and the load distribution. So the better forecast, it will be the better planning, and also it will be you will have the resilience and the availability and the redundancy of the system in order to contain any severe incidents occurred in the system and restore back to the normal situation.
Yeah, that's very interesting around the resilience topic and understanding the down to the customer and back up to the system level. So
yes,
ability to kind of bend and don't break and not actually cause the system to go dark. Anyone else thinking about the resilience topic? Yeah.
So I'd like to build upon that. So you mentioned these, weather events that happen. So, for example, one that happened in the United States was this. I think it was the winter of 2022, where this very severe ice storm hit Texas, and it even froze over the gas wells. So the resiliency of the system, renewable energy was not available, conventional energy was not available. They didn't have much interconnection with the rest. They're essentially an electrical island. I think they only have about 800. Please correct me. 800 megawatts of import capacity. Yeah. So because of all of these factors, then about every decade they get this. They had this severe storm back in 2011. It ended up happening again in 2022, and large parts of Texas went out, including, I believe, the refineries as well. Right. Is that? And so part of this resiliency is actually weatherization, building up capacity of the transmission grid, so that if these events happen. So, for example, they've happened in Oman, actually, where there was severe flooding. I believe last year in the Emirates there was severe flooding in Dubai. And so weatherization, weather forecasting systems, these would help you, plan, foresee these events, within the hours ahead, and then you could take action as well.
Yeah, that's actually. I might actually just skip to you, because Dr. Yusuf brought up something very interesting around the Texas event, where interconnection helped a lot, or would have helped a lot. We saw similar things happen in other parts of the country, but they didn't see the load shed that you saw in Texas because they were interconnected. So maybe on the GCCIA side, is there some thought around the kind of resilience value and resilience from a GCCIA perspective?
Yeah, so we are already integrating actually the resiliency part in the transmission planning. So we are looking into that with the low probable, high impact events, let's say. We are already integrating that into the transmission planning aspect. One of the things now, though, for the adequacy part on the, let's say, in the in the system adequacy side. I mean, luckily for resiliency, luckily or unluckily, we have extreme hot weather every year, so that's not a problem by itself. But one of the things now we are trying to understand is how the sandstorm impact on especially the PV, obviously. We have extreme cases, not exactly midsummer, but let's say around summer, May, June, where we have a sandstorm covering the whole sky for 2-3 days. So how that would impact the PV, that is something that we are trying to understand in the near future.
Yeah, that's going to be really important in this region, is understanding the frequency and what that really looks like, how widespread it is, those types of things. I'm looking at another question here, and one of the topics that we hear a lot about, and Engineer Ahmed, you talked about the real-time digital simulator, but kind of even almost moving beyond that, the digital twin concept, and wondering if anyone in the region here is looking at this concept of a digital twin that they're developing to really understand what's happening on their system and what that might look like. And I don't know if anyone's got specific things that are going on in that particular area. Is that something that might be interesting, is being able to really replicate what's happening in the power system so you can study those types of events? And what's still needed to get to that point before we can have something like a digital twin? So I'm not sure if anyone wants to start, or I should just pick on someone, Moed maybe.
Yeah, I've heard one word I think that's important, but I will first start saying that part of it's not an issue, it's just it is what it is. With today's tools, they are designed, let's say they were designed like 10, 20 years ago. So it takes time for the simulation. Now with more complex modeling, with more constraints in the modeling, it takes days and sometimes weeks if we are including the flexibility part into the adequacy as well. But I've heard a good word that it might be a key solution, which is the AI. It can be a solution, or a mix between AI and the, let's say, faster processing with co-simulation and so on.
Yeah, absolutely. All the high performance computing, I think, Dr. Yusuf, you mentioned that earlier, the need for bringing some of those in. So we're starting to kind of run towards the end of the time here. I was thinking something similar to what we've asked in some of the other panels, some of the kind of key challenges, but I might target it around time frame. So we've both operators and planners here in the panel, and thinking about things tomorrow and then thinking about things in 2040 or 2050 when you're hitting these net zero goals. Which time frame or which aspects of the energy transition concern you the most? And just to give some context, the US recently, with a lot of the demand side growth, the data center growth, a lot of people very concerned that towards the end of this decade they might start seeing some big challenges. So is that 5-year time frame concerning for you? Is it a 20-year time frame, or is it next year? What's your biggest concerns? What keeps you up at night? And maybe we start, Engineer Aisha, if you.
So I'd just like to highlight here that in Qatar, we already started integration of the renewable energy before 2022. And we are moving forward with a clear vision and ambitious goals. And it's, so for example, we have a target by the end of this year, and then we're adding on this target to reach around 18% of the total generation to be from renewables by 2030. And this will continue, obviously, towards the future. So what concerns me here is that 2030 is very soon. Yes, we do have, we are already in the process. We already have an example. We have ongoing data. However, studying or analyzing the data that we're getting from our current plant and projecting them to 2030, I think is very challenging, as it's very soon. I mean, even in terms of technology or tools to be used addressing our target in 2030 are being, let's say, advanced or a process. So there are ongoing studies, for example, on storage, how to make them with different technologies. So even like if we want to go and start implementing storages in our system, I don't think we are in the optimal or ideal time to start now. We need those studies to be finalized to get into the most advanced technology in our system.
Thank you. So really understanding that the studying and understanding when you need certain types of resources and where you need them being important there.
Exactly, yes.
Maybe Omar.
I would say the most challenging period for me as a system operator is going to be the medium term, because you're going to end up having, let's say, within 1 to 3 years. This is the period that's critical because there is no project that normally comes in power grid within 3 years, whether it's call it batteries or power station or any grid upgrade. So operability studies that now being done within EWIC, like by Bruce teams, is actually something that we have started in the recent years that's helping us to understand what are the risks that we as a system operator will face and what possible solution that will be available for us. And in case some solutions that are not available for the grid, then we might approach some power plants to increase their flexibility and invest there for a short-term solution, and also maybe approaching some customers and approaching the regulator to support us to make sure that we can operate the grid securely and safely.
Yeah, that's interesting. So really you're trying to understand what you could do in that immediate term with the technologies we have and getting those together. Maybe Moed will go to you next. But what are the big challenges, big time frames?
I would say let's say for the next 5 years or even less, there will be a lot of challenges for the operational aspect, day-to-day operation of the system. Luckily for us, though, we have a lot of already built-in generation, thermal synchronous generation. That would help us. But of course, it means just additional costs. We will need to burn more gas, for example, to operate the system. So the solution is there, but there will be a cost associated with it. I think, though, for the long term, it's a bit, I wouldn't say unclear, but depending on what direction we go, for example, when it comes to long-term storage, obviously that can resolve a lot of problems, whether it is system adequacy or even flexibility, or somehow it can resolve a lot of problems. So in the short term, there will be operational challenges. In the long term, beyond 5 years, or even within 5 years, we will start to feel in the long-term planning as we go higher and higher. So, for example, we often plan the system, or we find a value for the renewables, but that renewables is for across the year. But what does happen during winter, for example, when we have a lot of thermal generation which we cannot switch off for whatever reason? It could be a constraint, for example, when it comes to the dual production between electricity and water. That would be a big trouble.
Yeah. So that's some of those long-term issues that we still have a lot of uncertainty around. Yeah. Dr. Youssef, maybe you could talk a little bit about what are there particular periods when you think they're going to be most challenging in the region? What time frames are likely to be the ones that really would be the most challenging to get through?
So as we build up, we're going to face these challenges with more and more renewables. I think what Engineer Ahmed mentioned, the integrating of the smart meters would really assist. Every time you go and you build a plant, you build a storage facility, you need to gain these experiences, and these experiences need to be, they need to be communicated to the rest of the region, and how they're because how we operate, the challenges that we're facing. For example, I believe one of the issues that we had at Shagaya was the frequency of dust accumulation on the PV panels and the frequency of the cleaning. That was how to address that. But also another issue was, like, for example, the degradation that we were experiencing with especially the thin film technology was a little bit more. The thin film PV technology was a little bit more accelerated than what was actually anticipated. So those need to be, communicated to to the rest of the GCC. And when we go and we do the next planning model, we have to incorporate that degradation of the thin film in there as well. So yes, the first year it'll degrade faster, but then we're also seeing even more, a little bit more degradation at year 5 as well. I think we're about at year 5. These type of challenges, we have to come together to know what they are, and I believe that this is the forum to help bring those about.
It's a really good point, and definitely a big piece of the discussion here is trying to share those things, because we're moving at a pace that's faster than ever before. We can't do that alone. We have to share practices, bring those back, and then implement them as soon as we can. So, Engineer Ahmed, I'm going to leave the last word to you. Is there particular time frame
actually
you're
a couple of things that keep me awake at the night to achieve the 230 targets. I think it is a massive target and it's a doable target to achieve it. But before that, we have to make sure that we are ready during these years. For example, the first one, it is for long decades we are building and preparing our system for the day peak. Before 2030, we'll start worry about the night peak because of the solar, absence. So that we have to make sure that we have a flexible system and the grid in terms of the battery storage, demand side management, cross-border trading and exchange with the other countries, and also to make sure that we have an open grid inside the Saudi Arabia by establishing a new high voltage DC connectivity. We have already in place now, already awarded the execution, the high voltage DC interconnection with the 7 gig, with 2,000 kilometers of the transmission DC lines with the 6 converters. So all of these mega and giga projects with the supply chain that's everybody aware of it, while the external factors that we have to make sure that this kind of a different project come on time in order to avail and make the system ready to accommodate these, large number of the renewable energy and different technology. And the top of everything, as I mentioned, I think whatever we did, if we didn't invest in our workforce by upskilling, reskilling, make them ready, will not achieve anything. So workforce readiness, it is a key corner and a keystone for make these different targets and ambition plan achievable.
Yeah, and I'm glad you finished on that. The people aspect of it, we can do a lot with the tools and technology, but unless we have the people who understand some of these issues and can work towards it, we're definitely not going to make it to where we need to get to. So appreciate that, and I do want to thank all the panelists again. I thought that was a very interesting session. We covered a wide range of different operating and planning topics. There was a lot of questions in the Slido. We didn't get to them all. If you do want to ask the panelists, maybe come up at the end here, and we can talk more about it at the break. But once again, I want to just give the panelists a round of applause and thank you all.
Thank you, Dr. Toohey. We would like to invite His Excellency Engineer Abdullah Diab, board member at GCCIA, for a group picture and honoring the speakers. Dr. Adrian Toohey, director at EPRI. Engineer Ahmed Al-Zahrani, Vice President of Operations and Control, Saudi Electricity Company. Dr. Yusuf Al-Abdallah, Research Scientist, Kuwait Institute for Scientific Research, Kuwait. Engineer Aisha Al-Muhammadi, Head of Transmission Network Planning, Kahrama, Qatar. Omar Al-Amri, Operations AWEC, Abu Dhabi. مؤيد الكاظم, Manager, Network Planning, GCC IA. Thank you, everyone. Let's take a group picture. Thank you for this session. And now, Midal Cables and Technology Highlight.
السلام عليكم. إذا تعذروني بتكلم باللغة الإنجليزية إكراما للحضور اللي ما يتكلمون اللغة العربية. It's my great pleasure to be here in this very distinguished conference. This conference is really something that I have, with a great pride, talked about in Africa. I also talked about a month back in Singapore, and I talked back 2 weeks back in Vienna, in all the conferences that I attend, to talk about what we achieved in the Gulf is, I'm proudly to say, I say it with a great pride, that is much better than what USA has achieved with their grid, what Europe has achieved with their grid, and what Africa is thinking about. We have something to be really proud of here, and it is just a few kilometers from here, is to see the GICC control room and see how it is administrated. It reminds me of a visit that I had to NASA control room, where I have seen somebody sitting beyond screens and controlling the electricity flowing from one end. Actually, they were following up with the satellites and space station, but the principle is one of the same. I'm very proud of what's being done. When we dreamt about this project first time as a cable maker, and we approached our Minister of Industries then, something like 25, 30 years ago, we thought it's a dream because it's going to cost $1.2 billion, and that money was too big at the time. Now we can see that that has paid off. I'll come a little more focused on Midal. Midal, we have been for over 30 years, actually 40, connecting. Our first connection was between Dimyat and Libya in Egypt. And then we kept on doing these grid connection, including we have done Bremen to Munich. We have just done, we just won another in Sweden. We are a major player in National Grid United Kingdom, and we are very much major grid player in Scandinavia altogether. We developed special cables for Denmark with high technology, because Denmark want to make themselves the hub for the region of that Nordic part. We also have done work in the United States, Canada, Brazil, Australia. So we are a global player, but as this is a GCC conference, I'd like to stay with what we've done. We have connected Jordan with Syria. We have connected Kuwait with Saudi Arabia. We have connected Salwa with Saudi Arabia. And then I'm looking at the different project, Iraq with Kuwait. We are under implementation, connecting Medina to Aqaba. And we are also under doing the same connection to Egypt. And the list go on. We've done a lot of work with Oman. a lot of work in all the GCC country. It's something to be very proud of, that it is a material that is local, engineering that is local, and it's done to the benefit of what I just mentioned, the most advanced grid, in my opinion, in the world. I'd like to say something, and I'm going to talk about the next revolution to the region. Last night, I was dined by some people from the northern part of Saudi Arabia, and I told them that while you think that this country was blessed with oil, which has happened to be in the east, wait for the next blessing that is in the north. The best irrigation is the line of the GCC countries. We can capture the sun, as one German scientist has said, there's a nuclear infusion going on in the sun. You don't have to build a nuclear reactor to generate electricity. We can just tap on it. And that's the simple reality. Is all what we have to have solar areas. Now, can Europe do solar? Not that easy. A, because they have a lot of clouds and they don't want to deforestation. Can Africa do solar? Most of Equator Africa, if they have to deforest, then they have done damage to environment more than benefit. While we can very easily do it in the GCC because we have the mass of land, we have the irrigation. It so happened that we always believe that the desert is barren. Yes, it is barren because one day it was forest, and then through the geological time, the universe has turned one way or another, and the sun become too hot, and it has burned these forests, and they turn into oil, and that oil is what we are enjoying at the moment. But there is another revolution to come. We have a green energy of no limit. We can generate this and either use it to become first part of the world that has zero emission, or freeze it in different forms. Green hydrogen. The West is really looking forward for that product. So I was telling the northerner people that they gave me delicious dinner last night. Thank you, and God bless you. Don't pray for istighatha, for rain, because if I were you, I would go and pray that you get a snowstorm on North America, because they will demand for oil, and the price of oil will go up by some $5, $6. That is the modern day istighatha in my simple Islamic mode. Alhamdulillah ala ay hal, and I am very happy to have delivered some comments with you. Thank you.
Thank you, Midal Cables. We will have a 30-minute break till the next session. Thank you very much.
صباح الخير يا ريس، بعد إذنك أول ما
We will start in a few minutes. ستبدأ الجلسة بعد قليل. Session 6 will start in a few minutes. Hello? Moving on to panel 6, Showcase Technology Expo Grid Enhancing Technologies. GETS is our next panel session, and it will focus on the role of grid enhancing technologies. Ladies and gentlemen, welcome our moderator, Mr. Daniel Brooks, Vice President of EPRI. Joining him, the speakers, the esteemed panelists, Ivan Pittman, Managing Director, Energy Impact Partners, Dr. Vera Silva, Chief Strategy and Technology Officer, GE Vernova, Dr. Adrian Timbas, Senior Vice President, Portfolio and Market Strategy, Hitachi Energy, Dr. Sankara Subramanian, Utility Market Leader, SAFT. Welcome to the stage, everyone.
We're saying a lot of.
All right. We're getting close to the end, and a lot of great conversation so far. We've had a lot of conversation around supply, end use, delivery. We're going to come back to that grid part and talk a little bit about what are some of those technologies that we can be deploying to enhance the existing grid as well as to expand the grid as we go forward and what those may look like. And that term grid enhancing technologies is sort of a buzzword that gets used quite a bit. Not sure if we always know exactly what we're talking about, but talking about things like dynamic line ratings and advanced reconductoring and power flow control and batteries and how all those can be used to enable better utilization of the existing capacity and to expand what we have. And so we want to have a conversation. We've got 4 great panelists, a little smaller panel here. We ought to be able to really have a good conversation, so looking forward to that. And just like I have with the other panels, going to sort of kick off and give each of the panelists a chance to sort of provide their perspective, but kind of with a question that I'll give them to guide that. And so Evan, start with you. Obviously with EIP, you guys are looking at new technologies all the time and sort of surveying the landscape. And just curious what your thought is in terms of these emerging technologies and what are some of these technologies? I don't know if we even have a good common definition of what a GETS is. So maybe sort of give us what your thoughts are and what you see in the landscape.
Sure. Definitely agree. It's a little bit of a nebulous term. First of all, thanks, Daniel. Thanks, EPRI, for inviting me here. And thanks for the wonderful hospitality from the GCCIA and the other co-hosts. Maybe if you'll indulge me just a moment, I suspect there's not a lot of familiarity in the room with who Energy Impact Partners is. So let me just kind of level set us on that so you guys understand the perspective I'm bringing to the panel here. EIP is a global investment management firm. We make venture capital and private equity investments, have about $4 billion in assets under management, and we're focused broadly on technologies within the energy transition. So anything that promotes decarbonization, reliability, affordability of our power systems and other energy systems. What's unique about EIP is that we're backed by a global coalition of about 80 corporates who have operating businesses and own assets that actually comprise the existing energy system. So in the United States and North America, we have about half of the investor-owned utility industry that support our funds, and a large and growing coalition of folks in Asia, Europe, and the Middle East. And we partner with those utilities and other partners to basically go scout the startups that are out there, the emerging technologies, understand which ones are going to be relevant to the energy system of the future, fund those companies, and then work with our partners to scale those up and deploy those technologies in the energy system. So we're very eager to do more work here in the Gulf region, bringing technologies we've invested in Europe and North America into the region, things like multi-day storage, things like low-cost electrolyzers. So we'd very much love to have some conversations with anyone in the audience to that effect. So on to the question, grid-enhancing technologies. So I'll kind of divide my answer, and I'll get to explaining exactly what I think they are, but I'll divide my answer to the question into kind of two buckets. Where do we stand from a research and development standpoint, and where do we stand from a deployment standpoint? And if you'll forgive a kind of American baseball metaphor, I'd say we're in the middle innings of research and development. There are commercially ready technologies that are definitely out there in this category. We're in the very early innings of deployment. So starting on the R&D side, again, we look at the world through sort of startups and the innovation that's happening in that ecosystem. I'll let my fellow panelists elaborate on some of the great R&D work that's going on among some of the more established energy technology solution providers out there. But in the startup world, we've tracked about 30 companies over the last decade that are building technology solutions in this space. And collectively, they've received about $1 billion in venture funding. I would say the majority of that funding has gone into R&D, but we are starting to see some of it go into sales and marketing and scaling up manufacturing capacity. Getting to the categories that comprise this, about 40% of that $1 billion has accrued to the power flow control and topology optimization category. So think about that as a suite of different solutions, software and hardware, that effectively route power flows on the grid around congestion. So things like altering the impedance on different lines, or using software to optimize the switches that you open at various points on the network based on congestion. So call it about $400 million that's been raised in that category. We've seen another $200 million or so raised in the category of dynamic line ratings. That specifically is the concept of deploying sensors out there that measure wind speed and solar irradiance and ambient temperature, and basically help you create a more detailed hourly assessment of how much capacity you can put on a line, given its ability to dissipate heat at that moment. And then the other big category, another $200 million or so, has gone towards the advanced conductor category, which includes a number of different technologies. Sort of the most we're seeing in the commercial realm right now are these carbon fiber composite core conductors that have better conductivity and efficiency, and therefore have lower line losses and the ability to increase ampacity by 2 or 3x over the prevailing conductor solutions. So lot of work going on, at least in the startup world. Definitely, is $1 billion a lot over the last decade? Maybe not compared to a segment like batteries that raised $9 billion last year, but it's a meaningful amount, and it's led to some commercial solutions on market. In terms of deployment, I would say DLR and advanced conductors are ahead of the game. You would think with the 40% raised by power flow controllers, that would be a little bit more widely adopted, but we have seen some challenges with execution and scaling of the technology in that space. So on dynamic line rating, we've seen a lot of utilities test the concept. Some start to scale it up globally. They're typically in these deployments, they're seeing anywhere from 30 to 50% incremental capacity uncovered in these lines across all hours. Of course, it's variable. It depends on the wind speed and the ambient temperatures. So system planners are often quick to point out that DLR is not necessarily a solution if it's a reliability concern that's driving the need to build out new transmission. But nonetheless, it's a huge opportunity to reduce congestion cost and integrate renewables and drive more affordability for customers on the grid. And then on the advanced conductor side, again, deployments in the field are showing that these conductors can go in, that they can deliver that 2 to 3x power transfer capacity in the same kind of physical footprint as conventional conductors. There have been some concerns and reservations around sort of the fragility of these lines and some challenges with how you have to handle them during installation and issues with failures in the field. We think that, both a combination of sort of adoption of best practices around installation plus some new technology innovations that are kind of pre-stressing these conductors and encapsulating them in aluminum is addressing a lot of those issues. So we're really optimistic about the future of that category. So that's where we see things standing. I'll leave it there and look forward to hearing what the other panelists have to say.
Yeah, that's a great survey of sort of the landscape. Appreciate getting us started. Vera, obviously, GE Vernova, leading technology provider. You all have what I'm sure you would call grid-enhancing technologies of various types. Tell us sort of about what you see as key technologies that are coming forward, whether they're more mature and commercially available or emerging from your perspective.
Thanks, Dan. I think my microphone is not on, so just 1 second.
I don't hear you yet. Is the green light on?
Better?
No.
There seems to be a do we have a standard microphone?
Can we get another mic?
Hello?
Yeah.
It's on.
Yeah, it's on.
Technology.
Yeah.
Thank you so much. This is much better now. So getting back to my thinking, before I start going through the grid enhancing technologies priorities we're looking at, I just want to get back to why we're doing and why we're choosing some of these. So today I think congestion and waiting times for grid access are being huge barriers to both connecting of generation, renewables, but not only, but also to supporting an increase in demand. This has been put even more to evidence with the arrival of new loads from data centers and now what we call the artificial intelligence factory. So the pressure on a faster connection to the grid has been mounting, and that's really a global aspect we have today. Obviously there's a delay at time that it takes to develop the grid, but an opportunity to see can we do more with new technology and the assets we already have. So most of you know that the grid has a high level of redundancy, stability margins, so we use about 30% of the installed capacity, and that is for good reasons, because resilience and reliability should not be compromised. But at the same time, all of this was calculated based on a certain type of technologies, certain access to data, and certain type of planning and operation tools that have been evolving significantly. So we've been really looking what are the different aspects that we can change with technology that allow us to utilize more of this capacity as an alternative to the new reinforcement on CapEx. So one of the things is very much like dynamic rating, but we actually look at it as dynamic system rating. Because as we look at the full substation and the aging models and the information we have on transformers or switch gears, we see a much bigger opportunity of, in some cases, load in a different way these assets and allowing us to flow more energy through the grid in certain moments. So the issue is how do we create the confidence and the visibility also from system operations level to know how to utilize this capacity. This is why integration of the data and having this ability to see it from the control and to dispatch this capability, it's been one of the things where we need to gain more, I would say, trust in the technology. So the work is being done both at system level as well as the substation level. The second reason why we need these margins is the stability margins of the networks itself, because we have capacities, inductances, and there's margins we need to keep. And this is where we're looking at fax devices. So power electronics is really a critical enabling technology as we go forward. We talk about it already for grid farming, we talk about it for reserves, but there's a huge opportunity of using these power electronics controls to better manage the stability margins of the grid itself, of the lines itself, and that will allow us to unblock new capacity. And there is a large portfolio of solutions, more or less advanced, from all the way from STATCOMs, SVCs, more recently unified power flow controllers. So this is an active area of research we're doing, both internally but as well as with customers. And I would say some of the solutions are off the shelf. It's about deploying, while others are in earlier stages of development. But this is really critical as we go forward with power electronics. And then we have the third layer, which are the things that we can add to the nose of the grid to change the way the energy needs to be flowed in the grid. And this is where battery storage comes, as we say, as a virtual line, because we can really manage the congestion using this storage that can be more distributed into the grid when compared to resorting to large centralized redispatched resources. So on BESS, or battery energy storage, it's one of the key applications. But in some of these cases, the challenge today is not so much on the technology maturity or the acceptance of the technology, but more, do we have also the right regulation that's going to support this type of technology, different to the traditional CapEx-based remuneration of grid investments? It might be different from country to country, but we need to make sure that we can create this level field play for these different types of technologies. So to summarize, what we can do with data, with AI, digital twins, seeing better the substation, dynamic system loading, what we can do better to stabilize the grid with an increasing loading of the lines with the power electronics, fax devices, and then how can we use technologies such as storage, but also storage in the customers or demand-side management to better handle in a more distributed way and managed by the grid operator this type of congestion so that we can create what we sometimes say, which is a virtual line. So really, in a nutshell, this is where the grid enhancing technologies fit in our strategy and portfolio.
Yeah, thanks. A couple of things that you mentioned there that we'll want to think about a little more in the conversation. Trust, I like that question. You know, how do we build the confidence in these technologies and solutions? We'll come back to that. And then regulation. Do we have the right market incentives and signals to be able to deploy those? So we'll try to come back to those. Adrian, obviously Hitachi, another technology provider, and we haven't mentioned HVDC yet, but I know that's something that you've spent a lot of time on, and that's obviously enhancing to the existing grid. Tell us your perspectives on GETS in general, but HVDC as well.
Yeah, sure, Daniel, and I'm glad to show the slides here also for the audience there, not only for Vera, who were talking very nicely to them before, because we see them all here. And you see, we are very well aligned, right? One of the technologies coming up in the future will be power electronics, and this technology provides so much flexibility and so much functionality that the future power systems will require. Obviously, HVDC currently, Daniel and the audience, it's a very popular product line that we have. And I'm just coming from Sweden straight here, where we have celebrated 70 years of delivering HVDC to the world. So back in 1954, we have connected the Gotland Island in Sweden to the mainland Sweden with HVDC. And then the history starts. From there, the technology was developed. It was not an easy way up, right, as the market for such technologies was not there. And traditionally, HVDC was used to interconnect different frequencies, like you experience also here in Saudi, right, connecting with a neighboring country on 50 hertz and 60 hertz, all for bulk transmission of large amount of power. They were the two main applications. However, the market for HVDC in the past was not a huge market. But as the renewable power, and particularly offshore wind, has developed tremendously in the last decades, starting in Europe, but then going elsewhere in the world, HVDC became one of the key solutions to interconnect and integrate this wind power into the grid. And one of the key functionality there, it is really the controllability of the power that HVDC links provide. And therefore, moving forward, I think this controllability that it brings into the grid, the stability that creates at the point of interconnecting with the grid, it is very much appreciated by the grid operators as renewables and all that intermittency that we have discussed earlier in the morning and was brought up by so many system operators here, it is at least more and more controllable. Sure, the power electronics will do whatever it can with the energy and the power on the supply side, and we know that both wind and solar are not that controllable. However, right, battery is, and Vera was alluding very nicely to it, but I would like also our next speakers to say more details about that. So combining these technologies, either within one power plant, when you bring the wind or the solar together with battery and then transmit it through power electronics, through HVDC links into critical nodes in the network, will be one way of integrating renewables, or connecting renewables, integrating renewables, and strengthening the grid at the same time. So that's a very interesting aspect, which I think we need to study more, because technology is there, and we have the capabilities to understand how this technology can deliver value. We need to take it into the problem statement of the respective grid and understand what the value creation is. Another aspect, and if you help me with the slides moving forward, which I feel was not too much addressed there, I said a lot about the power electronics. They will be in every single point of them, and depending on the energy source that we have there, they will provide a certain amount of flexibility, stability, and even reliability on the system. And this goes back to system design and system planning. How do we control and where do we put these nodes? And the next aspect, which I would like to highlight a little bit, it is that throughout these 2 days here, we have been talking a lot on the pathway to net zero and a lot about making the electrons greener. However, we also need to make the assets greener. Right? And here again, together with our colleagues at GE, we are riding the game on taking, for instance, the SF6 gases out of the braking, right? And making those breakers have a carbon footprint very close to zero. And that is a very important aspect that we also need to address. In this very city here, right, we have a large factory for our switchgear, producing close to 2,000 bays per year. And as soon as those requirements for sustainable breakers will come, we will be ready to deliver sustainable breakers out of the factory here for the country and for the region. So again, don't want to repeat too many messages, but technologies to drive this net zero are a lot there. And the last aspect also moving forward with the slide is a lot discussed earlier today about the digital, about the tools, about the connectivity, about learning what we do from the data, how do we utilize the data to drive better decisions. And yes, there are a lot of challenges ahead of us, but only looking at a relatively limited number of people in this room here, we had a lot of ideas what can be done. So I think the next step is let's go and do it, and doing it all together, because otherwise we will not have the impact, neither the speed nor the scale that we need to do it and reach the 2050 targets that we have.
Yeah, thanks, Adrian. You brought up a couple points there. One I hadn't even thought about really as part of our conversation, but I think it's very relevant. Extending the life of existing assets with, GIS replacement for SF6 or whatever, being able to do that. That's something we want to try to maybe talk about a little bit more as well. So Vera, Adrian, you both mentioned batteries. I could see Sankar down there just getting really ready to talk. Obviously, SAF being a battery provider. How do batteries play in? The conference last year when we were in Dubai together, we had a good conversation around batteries as a transmission asset. What are your perspectives on batteries and storage in general as a potential grid-enhancing technology?
Thanks, Daniel. I'll possibly answer this in 3 parts. Start off with a very quick introduction about SAF. Given that there are no battery players in this room, very quick introduction about SAF. SAF is an 105 plus years experienced battery manufacturer producing time and mission critical products and solutions. In 2005, they diversified into the energy storage systems for renewables and in the grid utility sides. And they have projects on both renewables, grid side, as well as C&I data centers, worldwide projects. In 2016, SAF were acquired by Total Energies, the French majors. The type of batteries they use are the lithium ion phosphate, LFP based, and given its characteristics of power and energy, it can able to be applied in applications from 0.5 hours to 8 hours. And most of the grid applications actually fall within that category. Of course, if it exceeds that, then you actually fall into LDES, long duration energy storage. Now to your question about how batteries help in the transmission. I think before we get in there, we need to visit those axioms of the challenges that the grid faces, actually. So as you may see there, the ratio of the non-conventional generation to the conventional generation is actually growing. And what that tells us is that we may need more and more of services on voltage as well as on frequency, not just the balancing services that we speak normally are used to. And then because of the growth of asynchronous generation, we see that quite good examples being Australia and UK, that inertia is very low in the system, and it is coupled with the system strength levels as well. So that's a bigger challenge. Then as we see that with more variable sources, been the talk over the last couple of days, what really actually translates is that non-spinning reserves, how do we have those capacity reserves? And France and Belgium are actually growing in those capacity services, as Texas as well. And then we move on to the fourth issue is that these type of generators are, when they connect to the distribution, the load centers are normally further away, and therefore there is also congestion that's happening in the system. So these are kind of 4 critical things. And as we see here that the world is fast moving away from the historical construct of base and peak load, actually. And it's actually moving towards the variable energy and firming up. Now, just now to turn the answer to your question, now there are actually 4 critical areas, Daniel, that batteries clearly play a role. Again, of those 4, 2 of them are for the preventive congestion, which is during the steady state that we have. There is congestion due to increased load in the system, and we actually have an innovative project with RTE, and we termed it as virtual transmission lines. So in a way, actually, it is energy shifting over space. The energy shifting over time, we are quite used to on the generation side, but this is energy shifting over space. So that's one part. The other one is actually N-1 contingency. It's corrective action, corrective congestion. So it's it's code-named under grid boosters, Transnet BW and TenneT in Germany. Those transmission systems already have or planning to install 250 megawatt, 250 megawatt hour, 1 hour storage systems in there. Lithuanian grid has already employed, and they are already operational as well. So that's the second part. The third part of it is, it's not very for transmission, but for distribution. It's what I would term as the virtual distribution capacity now. And this problem is very seen across the Middle East, is that when you have in the secondary or the primary distribution system, that both the main 1 and main 2 transformers are being overloaded and they actually trip as well due to the loads. Kuwait experienced a lot during this past summer, and therefore what you could actually do is we could use those transformers. In fact, Stedin in Netherlands also has this problem. We could use these transformers for base load, and then you could actually use the BESS for the peak load applications. That's one of those third applications. The fourth is inertial support. Now, this is one, I think we have been talking about inertia a lot those last couple of days. Here's the number. A reduction of 100 GVA seconds of inertia leads to 0.3 hertz in the system. Okay, I give you a classical example. What happened on 22nd December 2023? The France-UK interconnection tripped. It was carrying 1.2 gigawatt of load, and UK was already operating under low inertial system. And what happened is that within 10 seconds, the dynamic containment of the battery is brought up within 6 to 7 seconds, 875 megawatts of load. We're talking real factors here. So this is one of those. And inertia, again, you could actually even use a grid following inverter and still do this application, but then it can be a little bit slower by hundreds of milliseconds than the grid forming inverters. We can dwell into that a lot when we get time on the sidelines. So these are the 4 applications, and inertia coupled with system strength, as we see in Australian market, it's one of those where we're trying to apply as well, because system strength is much weaker there due to lesser interconnections within those NEM region and the WEM region.
Perfect. Obviously, batteries have many different potential applications and use cases, and
the new applications that we're trying
exactly, starting to emerge. So, I've not done the best with getting questions in from your input from the audience, but if we can get the barcode up, I'm going to do a better job. If you've got a question on grid enhancing technologies, get that in. We'll make sure to get that question to the panelists as we go here. I'll get us started, and at this point, just conversation between us. So much potential and opportunity with the things that we just talked about: dynamic line ratings, advanced conductors, HVDC, life extending technologies, batteries. Why are we not seeing more application and deployment of those? At least in the North American context, a lot of that is still, even though commercially available, applications for maximizing the utilization of the existing grid or extending. Not as significant deployment. What are the barriers? What's stopping us? Anybody jump in?
Okay, please go ahead.
I could start just to say there is the business case, which is challenging often to provide then an investment in CapEx, and so it's very much about how the regulation and the investments are approved. So that is, if we want to pick one reason why it's been challenging, and I speak more from the European context, that is the number one. Secondly, I feel the technologies are being adopted, like in many cases, like what Adrian mentioned, HVDC, it's growing. We have many of the things are taking up. It's more on this moving from CapEx, hardware-based grid enhancement into these new technologies. It's much harder to prove the benefit, and hence I can see the investment doesn't get justified in the same clarity as just the hardware investment.
Yeah, go ahead.
If I may just follow up on what Vera was saying, right? We have installed about 350 HVDC systems around the world, and about more than 10,000 fax devices utilizing power electronics technologies. And I think now the system operators are quite familiar how to use these technologies and where they brought value to the system. Moving forward, we see even more value could be created, yet, like Vera said, we need to demonstrate and we need to articulate that. However, there is one aspect that we used to have in the past, that every system was special, and we needed a lot of engineering time and spending a lot of time in designing it for the particular application. With the situation that we have right now, with the rise in the demand and the installation of systems and quite a bottleneck supply chain, what we see a lot of tendency right now is for system operators to kind of start already harmonizing the application of technology. I give an example what TenneT was doing with all supply chains, we, GE, and even Siemens Energy involved there, and they put up a tender for 12 systems, 12 HVDC systems totaling 33 billion euros, and all under the same requirements. So really harmonizing and standardizing the functional requirement, it was mentioned earlier today, across the planned horizon between now and 10 years ahead to deliver what Germany and Europe will need in terms of energy transition. So that for me would be one of that prerequisite. You mentioned, Daniel, and then I let Evan speak, but you mentioned US, right? So there is a little bit of a difference between Europe, where we have a tendency to harmonize by the ENTSO-E, the Association of TSOs, and then the North American market, where you have so many ISOs, RTOs, and then at the state level, a lot of system operators, and that harmonization is not there right now. So really you have a bouquet of customers with different ideas how to use the technology. And this is why GCCIA is so important in this region here, to get the countries together, to align on a vision, to align on a plan to implement that vision, and then work with the supply chain, work with all the stakeholders, because we will need regulators, we will need the policymakers, and we will need all the technologists and the brains in the room to make it happen.
Yeah, so common theme there, but keep hearing that regulatory investment process to be able to get there is going to be really important, and having that structure. And you're right, the U.S. is just completely dysfunctional in terms of sort of the federal versus state and the different jurisdictions. Investment,
I'd maybe put just a little different nuance on that. I think, so we all know the phrase sort of necessity is the mother of invention, right? Yeah. Or in this case, necessity is the mother of adoption. I think to this point, it's just been entirely possible to operate the grid in an affordable, reliable manner without GETS. And that's becoming less true in Europe and Australia and other regions of the world where higher renewable penetration has led towards kind of more urgency and attention to this problem. In North America, we haven't reached those level of penetrations yet, but now we have massive quantities of new load knocking at the door, and our utilities are quickly finding that they're unable to secure the land rights they need to build new transmission to serve that load, or if they are, they're going to tell that load it's going to be 7 or 8 years before they can serve it. So I agree with my fellow panelists. There are definitely regulatory and business model issues. There are even plenty of operational issues, like for dynamic line rating, updating your EMS to be able to accept, changing sort of line ratings and account for that in dispatch. But to me, those latter two barriers fall down. Like our utilities in North America are very good at working with regulators to find solutions. Those fall down as soon as the necessity is there and as soon as it becomes a priority for the industry, and I'm seeing that start to happen.
A couple of points here. I think even from the storage perspective, the normalization of the vocabulary across the Atlantic is going to be very important. So you have SATA, is storage as a transmission asset, storage as a transmission only asset across there, and then here you have grid boosters. So that's one of those. I think we can get them sorted out. But also the transposition of the best practices has to happen. I think, say, for example, if you have grid booster, and I already see in Mysore Central in Indiana, I think they're already trying to go for grid boosters. This is very good, as well as in the Baltic countries, they're trying to go with the grid boosters. So we need to transpose these best applications elsewhere too. This is number one. And in terms of FERC, I think FERC has been quite active over the last couple of years. We see the rule number 881 with particularly for the grid enhancing technologies, as well as for BESS. I think they're bringing in some incentives. Now, that could be in different way. We could call it as constraints. And the same we're trying to impose onto with Acer as well to push NSOE in Europe. And I think there are some things that we can take away with the other regulators in GCCA as well as in Asia Pacific regions as well.
Yeah, I want to pull the thread just a little bit on, you said necessity is the mother of deployment. There is risk with new technologies, right? There is risk in, maybe even if it's not a new technology, it's a new implementation of an existing technology. And one of the questions that came in from the audience is, the risk appetite in some regions may not be as high as the risk appetite in other regions. What suggestions would you have, particularly in the GCC region, in terms of how companies can work together, both operating companies as well as with technology providers, to sort of de-risk that implementation of these new technologies as we move forward here in the region? Yeah, Adrian.
Yeah, if I may start, and I have, again, working with a lot of regions from my role in Hitachi Energy, and I think risk is always associated with knowledge how to do certain things. And what I have learned with other regions is that they go around the world and find out where similar problems have been solved, right? And I can tell you, I took a lot of Chinese to Europe, I took a lot of Japanese to Europe, and we went to Australia, and we went together to other parts of the world to exchange information, to look at similarities in problems and how do we solve them. And this has been very, very useful for the receiving part to understand how it is done. And then, secondly, I will just strengthen my previous message. We are a team all together. We are in the same boat to get to net zero, and we need to work all together to get there. Otherwise, it will not be possible. It will not be feasible. We see challenges to get it feasible, even like it is today. So if we are not working as a team across the supply chain, across the stakeholders, it will not happen.
Yeah, go ahead, Vera.
If I may pick up Adrian's, so I think collaboration is really essential. And I mentioned before that having access to the right level of expertise, skill, resources, engineers, is perhaps one of the most challenging pieces of the supply chain, and that is for all the regions, and it has to be close to the customer, and hence it's also a region aspect. And the collaboration in terms of de-risking and understanding the technology to find what is the best standard for the different types of grids is going to be key, and that's where GCCIA plays a key role. And just to give a precise example, SF6 replacement is one of the big stakes in terms of how we decarbonize the industry. There was a slow progress until there was a collaboration with Hitachi, and it then moved a massive uptake and tons of CO2 saved. And that was one of the first things. When it comes to HVDC, how do we move into a multi-terminal DC grid? Again, an aspect of collaboration. We have multi-terminal, multi-vendor projects between different transmission system operators and different OEMs, so that we can really take a step forward in such a big technology step. And these are concrete examples that could come through and also support the region with the different players, local, and bringing more R&D and collaboration.
So I want to dig a little further on, you said understanding the technologies, Vera, and earlier you said trust. It's almost a chicken and egg kind of thing, right? In order to understand the technologies, in order to develop the understanding of the performance of those technologies over time, you have to have deployment, but there's hesitancy to deploy until you understand the technologies. What can we do to sort of cross that bridge in order to ensure that we're getting those technologies out to learn from them? What might you suggest to get us past that hump, if you will?
One of the things that I've been observing, not always with the transmission industry, but when we go to other industries that also develop high voltage level of grids, it's a much earlier collaboration between engineering and R&D teams. To start the first pilot solution, to be very involved in the development process and have the same understanding of the technology and the pilot. That is definitely a very key aspect of this. So this is one of the solutions, and the second one is this type of projects where the different key players get invited around the table rather than waiting to send specs where we all work on one side and then OEMs will receive the specs down the line and start then doing the project. We have a decade. So these are two ways of accelerating technology that I have observed.
Yeah, and I will call that also co-creation, right? I think everyone was saying that there are a lot of money, right, to be put into innovating new solutions. I think whereas saying there is a lot of know-how, right, in the supply chain to understand how to do that, but we need to co-create together and go look at, again, the problems need to be solved. Was mentioned earlier about NEOM and what the team of Innova was doing, right? Building that plane and flying at the same time, and that is what we have been working with them to do that, right? Yeah. So it was very close collaboration. Every single step we challenged and we revised and so on, but yet, right, from a white sheet of paper, they came up with a master plan of their grid. They start implementing their grid, deploying the systems in place, and start putting it up in a fantastic speed. We haven't seen this speed happening in our industries for a very, very long time. And needs this kind of approach, this kind of characters, right, to put things on paper.
Daniel, I think to your question about GCCA, what could be, so the more you're going in for renewables, I think firming up is basically needed. Therefore, you could actually build up your capacity reserve. So that could be the starting point, the non-spinning reserve. So you could think of those periods of the day. So whatever the resources are, it doesn't think agnostic of the technology, and then you could say, okay, these couple of hours I may need some, which it could be in battery, it could be something else. And then based on, so that would be one of those services which would have to evolve. So as it evolves, then the remuneration part also has to evolve. So that's another larger topic by in itself. We keep that aside for now. Then the second area would be modeling and then looking at the inertial requirements of their specific networks and then see what could actually support theirs. There was some lovely discussion in the morning. I completely agree with them. So adequacy and resilience, and so it's basically very important, and then you can bring in those technologies as well. But the immediate thing is building up the capacity reserves because you are moving on with renewables.
Gotcha. I'm going to transition this. We're 6 minutes left. I'm going to combine two questions from the audience and sort of quick answers, maybe 1 minute, but what one technology is under development, sort of R&D at this point, that you think has real potential to make an impact in terms of enhancing grid as we go forward? And what's a timeline for when that might start to actually come to a commercial state? So two questions in one.
Yeah. So the grid forming inverters are, just in our case with batteries with PCS, power conversion system, which is the grid forming modes. Now, again, that is already developed. In some cases, people are developing to actually also provide the system strength support and so on by injecting reactive current. And so that is going to actually, it's actually mimicking it's like in virtual machine mode when you build up with the black start applications. So you're actually calling it as a virtual machine mode. And the ability to feed the fault current for a few hundred milliseconds, therefore the grid codes can be met with and so on. So that to me, in my space, is something is going to actually make a difference.
Yeah, and might just extend that, not just the grid forming inverter control, but the interoperability of
these controllers.
Yeah, really the next step to get us forward.
That's the next step.
Yeah. Anybody else?
Yeah, I think that's a very good point. And if I would take it from two angles, Daniel, to answer your question. One, we need, in the situation we are, we need to scale up and we need to speed up. Yeah. So scaling up, this interoperability will help us, right? And Vera already mentioned the HVDC meshed grids. It will require this type of control, it will require interoperability, it will require next generation of embedded digital solutions to get there, even possibly next generation of power electronics. But we cannot continue connect wind farms one by one to the system. We need a grid that brings that hundreds of gigawatts of power around countries, around consumers. And then that's the scale-up part. And the speeding up part, I think we as an industry, not looking deeply enough into the digital technologies that help us speeding up. It was mentioned earlier in the planning, operating, yes, we need to do, and we understand. But let's look at other industries, how they did it faster. Because if you look at right now, the digital industries are the fast evolving industries, and there is development every single day. Every single day you read about a new breakthrough technology or problem solving there. We need to bring it into our industry. We need to be more digitally savvy and drive that forward. Again, plan, build, operate, maintain across the entire value chain that we do.
Gotcha. Vera, do you have a thought?
I would stay for all of the above, because, and then I would bring, again, picking up on the digital and coming with a concrete example. I think digital substation has a huge potential in terms of having fully interoperable system configuration tools, digitize protection and control. This will hugely accelerate the ability not only to deploy, but also to upgrade, configure, and maintain the substations of the future. So it's an important building block.
Evan.
I'm going to sneak in two here, but
Okay,
I'll keep it to a minute.
Go.
My first one would be solid state or semi-solid state transformers with applications at the distribution level. We've seen some pretty clever innovation, innovating a little bit of power electronics into conventional transformer form factors that allow for a lot more A, visibility, they're communicating devices, and B, precision, kind of voltage and power quality control down in the system. That'll go a very long way to helping integrate DER. The second one is high-temperature superconductors in overhead applications. A little bit further out from a commercialization standpoint, but there are companies that are actively investing in and developing the cooling solutions that are necessary to make that possible. And that can start to unlock something like 10x power transfer capacity in the same footprint that we deal with today.
That's a great basket of emerging technologies that don't usually get talked about with GETS. So my clock that was telling me that we were out of time actually disappeared with like 3 minutes left. That was like 3 minutes ago. But I'm going to take just the liberty to give you 30 seconds each. Question I kind of ask at the end of all of these. So for the GCC, what one thing would you suggest or recommend that you would say if you really want to take advantage of these grid enhancing technologies, do this? What would it be, Sankar?
Yeah, build up the capacity reserves. You need to firm up because we are dealing with intermittency. It's no more the previous era of conventional supply. Therefore, we need to actually build up the non-spinning reserves. That would be my main call. And then we keep modeling country by country, and then we could take case specific.
Yeah, Adrian.
For me, it will be collaborate and align. We need a vision, the same as Europe has put their own vision there, and we see how they drive to supply chain. I think this region here can do the same. Collaborate and align. You will get everyone else behind you.
Perfect. Yeah, Vera.
I would say continue driving this interconnection between countries and coordination across.
Again, collaborating in a different way, yeah.
Staying in that theme, collaborate to test and prove the value. And I think there's great resources at everybody's disposal here, like EPRI and GCCIA, and EIP would like to play an increasing role in that, but let's get together, problem solve together, fund the risky initial funding together, and learn and scale up.
Perfect, yeah. Collaborate or die, that's the theme of the... So give these folks a hand. Thank you very much. Appreciate it.
Thank you.
Thank you, Mr. Daniel, and all the speakers. We would like to invite His Excellency Engineer Abdullah Diab, GCCIA board member, for the honoring and the group picture. Mr. Daniel Brooks, Vice President of EPRI. Mr. Ivan Pittman, Managing Director, Energy Impact Partners. Dr. Vera Silva, Chief Strategy and Technology Officers, GE Vernova. Dr. Adrian Timbas, Senior Vice President, Portfolio and Market Strategy, Hitachi Energy. Dr. Sankara Subramanian, Utility Market Leader, SAFT. Let's take the group picture. Thank you, Mr. Daniel, and to all the speakers. We will just have a few minutes break until our last session for today, entitled Showcase Technology Expo IA in the Power Sector. Just a few minutes. Our last panel session in this remarkable two-day forum, Showcase Technology Expo, AI in the Power Sector, moderated by Senior Vice President of EPRI, Engineer Neil Wilmshurst. Joining him are the speakers, Guy Gerets, EMEA at NVIDIA, Mr. Yusuf Jawad, Director at Microsoft. Welcome, everyone.
Is this on? Yes, it's on. Okay, well, we come to the last panel. So let's get started on artificial intelligence. And as I look back on the last couple of days and the conversations, so many of those conversations ended with something like, and then the miracle happens, AI shows up. So I thought I'd ask a question to the room. How many of us understand or think we understand AI? Okay, I see one hand, maybe 1.5 hands over there. And that's really the point of this panel. I don't think we're going to get into what seems to be the favorite subject in the power industry at the moment about power demand for data centers. What I think we really want to get into is where are we with AI? Where is AI going? How could we use AI? And how do we organize to use AI? And as a context, there are a number of consultants out there are talking about AI, and there's this, what they call this curve of anticipation. Everyone's thinking AI is going to be really powerful, it's going to get more powerful, more powerful, more powerful. But there are some voices out there saying we're about to hit a curve, and is there going to be a trough of disillusionment as we understand reality? I don't know which way it's going to go, but we're very fortunate to have the smallest, but I say the best panel of the event. We have Guy from NVIDIA and Jawad from Microsoft. So what we thought we'd do is let the panelists have 10 minutes or so just to give their perspective, and then we're going to get into some questions which will hopefully be open-ended enough that we can explore some issues. But what I would urge people in the room, people online, use the Slido app, ask the questions, because remember, think about this. Do you really understand AI? Do you really understand where AI is going? Do we understand what the power industry needs to do to lean in and leverage AI? So with that, Guy, over to you.
Okay, thanks. So first question from my side is, how many of you have heard of NVIDIA? That's great. Okay, that's more than a few years ago. So what I did want to do was to explain firstly why we're here, and secondly how we're working, because we're working with a number of industries, and this is one of them, and this is a fundamental one, which is energy. We also have a business model which is quite unusual. We are not a vendor taking on the whole world with something. We are actually working with everybody that we can. So all customers, all partners, whoever they are. We want to be the platform for AI. We feel we've been pioneering the whole idea of accelerated computing. I've been in the company for 12 years, and I was aware of the company and working with them for another 12 years before that. Long ago, I worked in Cambridge, where they were very excited about something called fifth generation computing. What that basically was the second wave of AI. To that end, Bristol company produced a coprocessor called a transputer, and that was supposed to do very fast, essentially computations, parallel computations, to enable all the AI applications they saw at the time. That just wasn't feasible. There was no enabling software, or was insufficient. So gradually that whole thing died. It's back now, and it's 3 reasons. Why? There's a lot of digital data out there ever since mobile phones became common, a huge amount, growing all the time. Some advances in software, and the availability of very powerful, cheap, parallel computing. And that is the GPU, fundamentally. This came about, well, I can think of 3 milestones. One in 2012, when an image recognition competition was won in Canada by a researcher using a GPU. After that, our friends at Microsoft, other cloud service providers were buying GPUs in bulk for their recommender engines, many things like that. 2017, Google produced the transformer architecture, and not to confuse you with the power industry, this is a way to handle natural language processing. It was a massive breakthrough. We also provided the platform for a little company called OpenAI, which surprised the world in 2022 with ChatGPT. So that's who we are. At the very basic level, we are a semiconductor company building GPUs, parallel processing, also ARM CPUs, data processing units, networking, and something called system on a chip. This can be a small device. The smallest one is about the size of a credit card, draws about 10 watts, and you can put it inside a mobile device, inside a drone, inside a robot, inside a camera. And that is a complete system capable of autonomous computation. Up from there, we have a lot of enabling software, system software, orchestration. Above that is acceleration libraries. Those form up into two main headings, AI and what we call Omniverse, which is really AI applied to 3D modeling and simulation all together, one platform. Acceleration libraries are ways to build applications quickly. And we now live in a data-centric world. In the past 20 years ago, you'd have some hardware, you'd buy your software from some known vendors, and you just use that. Now, people have realized they have data, all data coming into the company, data circulating around the company. We have to now industrialize the data because it's extremely valuable. Extremely valuable. And companies have to change to reflect that. And then they can use AI as a platform. Above that, we have frameworks which can then be reused for particular applications in different vertical domains. I work in the energy vertical, so I can talk a bit about other verticals, but probably no time here. What I do want to do is to explain what we are trying to do in this particular industry. Next slide. So there's four things, and we've discussed them many times in the last day or so. The first thing is, of course, the subsurface. That's where GPUs have been deployed traditionally in upstream seismic imaging. Aramco, down the road, has one of the largest installations worldwide doing subsurface imaging. It's one of the most important components of their exploration and production activity. They also have reservoir simulation, and we also have that applied to another problem, which we've also discussed a bit, which is CCUS. Where do you put all this CO2? How can you sequester it? How can you make sure it's not escaping or leaking? And how do you do that quickly? Because you can't spend a day waiting for a simulation to run to see what's going on. You have to have a fast way to check on that, monitoring method, which we've shown is possible with AI. And I won't explain how, but it's a quick way for an engineer to see what is going on. Second area is in surface facilities, and this is the domain of digital twin. I mentioned Omniverse. This is a way to create a photorealistic model of the actual asset, whether it's a single machine, compressor, whole refinery, whole campus, and then to be able to simulate what that thing does, is supposed to do, and what it's actually doing based on the sensor feeds which are coming into the model. It also applies to robotics. We work, and this industry works in hazardous environments. In the sea, bottom of the sea sometimes, tops of mountains, in the desert. You need to have robotics to assist with that. You need to minimize the amount of human activity that's necessary to go into those dangerous places. So we're very active in robotics, and that covers a lot of things. What you can do with a robot, you don't just build a physical robot and then try to make it do things. That's extremely dangerous apart from anything else. You build a virtual robot. It only exists in virtual space. You can make hundreds of them, and you can put them into virtual environments and train them over time. And those environments have to be photorealistic so that the robot can know what it's doing, where it is. And then you can deploy that GPU, that brain, into a physical robot, and then it supposedly will do what it's supposed to do, which is to do remote inspections, whether these are in dangerous environments where there's toxic leaks at the bottom of the sea, flying in the air, inspecting transmission lines, etc. So that's the second area. The third area is decarbonization, which basically means electrification. I think we all agree on that. Electricity demand is going to double by mid-century. That cannot be done by the oil and gas industry anyway, because global oil and gas production is pretty flat. I don't think it would be able to provide all the extra energy necessary, even if it was allowed to. So the energy transition is obviously a reality, and that means we're looking at wind turbines, solar panels, nuclear, etc. And we are engaged with all those companies actively involved in that. Siemens Energy for wind turbines, Hitachi, you just heard about earlier. We have engagement in the nuclear field, new modular reactors, SMRs, EDF. The final thing is grid modernization, of course. How does a grid stand up to all of these new sources of energy going into an existing grid, which certainly in Europe and the US was not designed to do that? All of those problems have been discussed, I won't go into it now, but those are the 4 areas which we're trying to address as NVIDIA. And I'd like to stress, we're working with everybody. We are the platform, we're not the solution provider. We look at what a customer wants to do. We figure out what the plan should be. We involve the partners who are going to actually deliver on that using the GPU platform. That's our model. We're not going direct. We go through a major system integrator, a major engineering contractor, an OEM, a system manufacturer, but we don't deal directly. We don't transact directly with the customer. We talk, but we don't transact. Next slide, please. So just finally, a couple of things. Of these various things which we all know about, I was at a conference in Bilbao back in April. We had a meeting before that with about 30 representatives of energy companies, and I asked them what were the 3 biggest concerns they had. The ones they came up with, the first one was cybersecurity, obviously. The second was vegetation management. Maybe not such a problem here, but it certainly is in many places. And the third one was weather. Next slide, please. Next. Okay. It's my last slide. We set up a special platform. Our CEOs mandated this to be able to model the climate. What our ambition is to create a digital twin of the Earth. So that will model the gross, let's say, dynamic activities of the Earth. And it is intended for various purposes, one of which is short-term weather prediction. That's using AI to create much higher resolution satellite images of weather. We did this recently with the typhoons offshore in China. If you're concerned about your built habitat, your people, then you're going to need a lot more resolution than 25 kilometers. You're going to need down to 2. And there's AI methods to do that, which we are working on. We've already discussed CCUS. We've already told you a little bit about what we're doing with surface facilities and with renewables and new energy sources. Beyond that, and this goes beyond the energy industry exactly, but it's also to advise governments on how to handle the extreme weather events and to predict them and hopefully to safeguard lives and property against them. And the last thing, probably the most important, is we are actively developing startups, inception partners as we call them, that often come out of research institutes and universities, because in the end, it's about having the right trained, educated people to operate all these systems in AI. I'll stop there, but that's essentially what we're trying to do. We are a platform. We're not a solution provider. We're certainly not a chip vendor. We're working with everybody, and that includes, for sure, Microsoft.
Okay, thank you for that. I remind you all, please keep questions coming, because this is a unique opportunity, and I'm kind of overwhelmed by the breadth of what you just talked about. I think that doubt about is the capability of AI going to keep growing? I'm convinced now it's going to keep growing.
Yep.
And the thing that I've got stuck in my mind is that concept of virtual robots.
Yep.
I'd never even thought of that till you said it. It almost feels like we're going to be living in that matrix.
Yeah.
It is mind-boggling where we're going. The question I have for all of us really is, how does this industry engage with that technology and get the maximum potential? And on that tee-up, you add Microsoft. I'd love to hear your perspective.
Sure, thanks a lot. It's a pleasure to be here. Thank you for inviting me to the panel. So I've been working in data and AI for the past probably 15 years. So I've seen this space grow. I've heard the myth about it, and I've seen the challenges about it. Now, if you ask me, is AI ready? I'll definitely tell you yes. Is it there to stay? Absolutely. Will it transform our lives? Definitely. If you look at ChatGPT, for example, when it was released 2 years ago, The technology was there before, but why did it go through all this hype? Because we took it from the enterprise and we gave it and put it in your pocket. So you have access to ChatGPT in your phone, you have it on your laptop, your kids use it, and that has been the transformation when it came to data and AI. That was the pivotal moment, and I want to stress on something. It happened because of the partnerships that we have with the likes of NVIDIA, OpenAI, and Microsoft. Now, let's talk a bit about practicality. Let's talk about AI today. What can it do for us? Can we use it? Can we trust it? Will it benefit us? We as Microsoft believe yes to all of those things, and we have been using heavily AI at Microsoft and with our clients. So I would like to categorize things into 5 aspects: employees, you as customers, process, innovation, and assets. And I'll touch a little bit on each one of them. So today, for example, we do believe when we want to come and look at our employees, we want to make them more productive. We want to make them more happy. We want to make sure that they get the best. Today, employees are quite expensive. And if you want to use their time, why don't we maximize it? So we come to productivity tools, and we brought AI and Gen AI to play a key role in your productivity tools. So Microsoft came up with a product called Copilot. So today, if you use Microsoft Teams, or your Outlook, or your PowerPoint, you can use Copilot to allow you to do things faster. You can write your emails faster. You can come in and ask Copilot in natural language, what are the most important tasks that I have today in my inbox? And it will bring them up to you. So productivity is key, very important. And I'll give you an example. A company like Uniper, for example, is using Copilot. Yeah? There are a lot of companies in the region are using Copilot for productivity. If you're having a Teams meetings, you have 20, 30 people, we are able to transcript the meeting, summarize it, give you the action points, and make you extremely productive in the click of a button. The technology is very powerful. So one of them is for employees. The other thing about Copilot today, because we believe every one of us is going to have a version of Copilot, and you can have a lot of Copilots. We are able to give you an assistant. So if you're looking into your enterprise data, you want to build use cases using your data, you're able to get Copilot to go into the whole knowledge base of your organization and converse with it. So if you have data going back 30 years, you want to capture the wealth of it, you can have a natural language discussion with it. You ask it a simple question in English or in Arabic, and you will get an answer. So that will give you a lot of productivity gains. When it comes to customers, for example, so I'll give you like a company called Vattenfall. We've been working with them on 24/7 matching. So Microsoft and Vattenfall, we created this partnership to match supply and demand up to an hourly basis. And we've done this 5 years ago. That was when we ran the pilot. And now this has completely transformed. And we're trying to expand it further into the market. So the technology of AI has been there. Yeah? And a lot of our customers are using it in the region, today in the kingdom, or in Abu Dhabi, or in Dubai, or all around us. We are using AI, and we're using AI heavily. But the challenge is not that the technology is ready. The question is, are we as people in those organizations ready for AI? And maybe we'll talk more about what we need to do to be ready for AI. From a process point of view, so today, for example, if you're looking into SMRs, we have created, in partnership with TerraPraxis, a solution that allows you to go through all the permitting, proposals, prepare all of those things for bidding for an SMR or putting the proposals for SMR so that it allows you to do things faster. Rather than writing the proposals yourself, getting all the compliances, writing all those federal documents, the software can prepare all of these for you automatically using AI and Gen AI. So the technology is ready. And so that is the third pillar on process. The fourth pillar, which is extremely interesting, it's called innovation. Now, I want to share a mission that our CEO mentioned. He said, the goal is to compress the next 250 years in chemistry and do it in the next 25. The reason is we've created something called quantum elements. Yeah? This is an AI engine for elements at Microsoft. So what we've done is we've partnered with one of the entities in the US to create new materials for a solid-state battery. And we created a new element that is not there, or a new compound that is not there in the market, it's not there in nature. We created it, we took it, and with the scientists, we were able to take it from the lab to creation and actually test it. And the nice thing about it is that it uses 70% less lithium, which is rare and expensive. So we are looking into how we can put innovation through AI to support us in at the elements and materials business. The fifth element is assets. Now, if you look at assets, probably this is the first place I'll tell you, you have a lot of use cases that you can deploy. You have predictive maintenance, forecast demand, grid management. You can do risk-based approach for how you do maintenance in your systems, energy efficiency. All those have AI use cases that are readily available that you can use. You can trust it, you can deploy it, and it will give you a lot of benefits. A lot of our customers have used it. We can give you references from the US to Europe, Australia, even here in the Gulf. But the scale of using AI has not been big, unfortunately. And it's not because the technology is not there. The technology is there, but we will need to look into the people, culture, and education part of it.
Okay, well, thank you for that. So I think as I sit here listening to this, I'm now convinced, if I wasn't before, that the potential is there, the power is there. We've had the conversation the last day and a half, and as I said, many of them refer to, and then the miracle happens and AI shows up to help us to control the grid and everything else. So what I'm hearing a little bit is the technology's there waiting for the industry to engage. It's the opportunities there to use the power of the technology today and get ready for the power of the technology in 5 years. How do you think the industry needs to behave differently to engage, to leverage these tools? Starting with you, Guy.
Yeah, I think also the industry has to realize this is very dynamic, and therefore very long evaluations, very long procurements won't work anymore. It has to be done quickly. Secondly, we have to think beyond the traditional idea of having a computer and then you feed it data. The entire grid in this particular case has to become intelligent. You have to build computational capabilities into each part of the grid, right at the edge, maybe even the smart meter, at the transformer level, gateways, all the way back to the data centers. You have to create this entire ecosystem which is intelligent and is able to automate certain things, but is also able to be robust, is able to be resilient, is able to take action quickly when problems emerge. One of the issues which no doubt will come out as we interconnect whole continents, I mean the whole of Europe and Middle East, the more sophisticated, the more complex, the more capable the system becomes, the more the danger that one day something will happen which will cause a catastrophic failure. So that has to be also considered. How do we use artificial intelligence to assist with all these different factors? How to maximize productivity? Obviously, wind and solar depends on weather, so we have to be able to predict weather much better. We're active in that. How do you then avoid, if you can, congestion? That's a major problem, particularly in Germany right now and the Netherlands. How do you minimize redispatching costs, etc.? So there's many, many, many use cases. The difference between high-performance computing at Aramco for seismic imaging is there's only a few codes, maybe 2 or 3 massive codes. AI has hundreds of use cases. You have to define which are the most important, which are the most urgent that you have to do now, and then you have to figure out the tail of other things you're going to do later. And that is a matter of ideation. It's a matter of meeting, hopefully with ourselves, our partners, to figure out what to do. And at that stage, who is going to be involved in doing it? Because it's the customer's own data. You own your data. You own your operations. You will need other people involved to deliver, but in the end, it's your project. It's not something you buy off the shelf. The platform is there to do that. There's companies here, there's Siemens Energy, there's Hitachi Energy, all ready to deliver whatever particular use case is. There's academic and research institutes working on this. So it really is a question of figuring out the use case, how you're going to use the platform, and who's going to deliver, what is the timescale.
Thanks for that. One thing that we as an organization struggle with in this whole area is information and data. So many companies have the perspective, which is accurate, that their data has value to them. And how do we actually move forward this AI activity and collaborate with each other? When you're using your own data, you don't just share your insights with other people. I'm still trying to process in my mind how we can collaborate in AI, but also kind of control the value of our own internal data. So maybe we'll come back to that later. But Jared, what do you think about what the industry can do to lean in more into this technology?
So I think I'll focus on two things. Okay? Just in the spirit of what everyone on the panel has been talking about. One is collaboration. And I'll stress on inter-collaboration within the organization, within the different departments, and external conversations with the likes of NVIDIA, Microsoft, and many others, even including your energy ISVs. Yeah? So collaboration is one, and the second most important one is the innovation mindset. If there's something constant in this world, is change. The world is changing dramatically. It is moving extremely fast. Today you talk about technology. Today we're talking about AI and generative AI. And if you come back after 2 years, we're going to be talking about a new technology. So the more you wait, the more difficult it is going to be for you to jump on the wagon, and the bigger the chasm for you to join the wagon. AI is not complex. AI is based on data. You have data today which is compartmentalized. You need, or my suggestion is, use the power that the digital world has so that we help you unlock those data, bring it together, and get insights across the organization. So today you'll have teams in generations, teams in transmission, teams in distribution, and other teams internally, and everyone holds on to their data because it's their crown jewel. The only value you will get is when you unleash the power of the data across the organization. And that is where real AI or generative AI can give you the right benefits. Yeah? Is it difficult? Nothing is easy, but you have to weigh the benefits that you will get. A lot of organizations that were able to harvest the data that they had were able to make better decisions, faster decisions, and they were able to make a lot of mistakes and learn from them in an agile manner and build a culture internally. Microsoft went through a dramatic transformation when Satya Nadella, our CEO, came. We were compartmentalized. We had a very difficult journey, and he opened up the company. And today, if you look at Microsoft, we are the leading, or one of the leading cloud vendors globally. We are one of the leading AI companies globally. We are one of the leading security companies globally because we were able to open up to the partner ecosystem that we have and open internally. So if there's one thing I would encourage that we can do, we have the skills, the mindset, and the capability to partner with you. And when someone like Microsoft comes and has this discussion with you, we bring with us a breadth of partners, the likes of GE, who are on the panel today, Siemens, anyone that works with you, we can bring them on the table because they're already a partner for us. And we can help you unlock the power of the data that's there. And then look at the people part of it. If you don't look at the people part of it, there's very little benefits that you get out of the data. It is this culture, this mindset. How can you allow people to innovate, iterate, and create something? You need to get them motivated. When they're motivated, they love their work, they do even more. And there's a lot of potential in the Middle East. I believe this becomes a key role that us as multinationals can play with you.
Thank you for that, and thank you for keeping the questions flowing. I've got 2 questions here which kind of play into the conversation we're having. One is around how do we maintain confidentiality and privacy of data when working with AI? There's another question around would the early movers get value by working with a third party to develop their AI tools? So it's almost into this dichotomy between holding your data close and collaborating and putting your data in the pool so everyone gets a way more powerful model. And perhaps this is something within the region here. Maybe GCCIA could facilitate some kind of collaboration around about AI use cases and collaboration of the data. Because I think what I'm hearing is these tools will be more valuable if people come together to kind of coalesce around powerful use cases and share their experiences, and then go into the training of the models, I presume, after that. So one thing I've learned over the decades in this industry, the way we improve is benchmarking. Go and find other people doing things well. Not necessarily in this industry, but in other industries. I'm wondering, gentlemen, are there any industries that are really leading the charge on deploying AI, and are there any lessons from those industries that we should learn?
Well, there are a number of industries we're working with. Healthcare is one. That's an interesting one because it covers a lot of things. It covers genome research. It covers patient records. So that is something which is, there's overlap with what we do in many areas. We're working in the retail space. That is, a lot of that is to do with supply chain logistics and so on. That's also highly relevant here. I think all of the industries have something to contribute to each other. The matter of confidentiality is really, you can be as secure as you want to be. That's probably a separate subject. I think the main thing is it's possible to use freely available or available large language models and tie it in with your proprietary data. That then becomes your proprietary data source. And that, I strongly believe, is the future of enterprise computing. It will radically change how enterprises do enterprise computing. And it also means, like I said earlier, we have to industrialize data. We have to industrialize how you collect data, how you curate it, how you structure it, and how you use it to train models. You won't need to train your own large language model. You will need to tie it in with your proprietary data through retrieval augmented generation. That's a technique which is out there. That is something that everybody can do, and it's relatively inexpensive. You can even use open source models for that.
Thank you.
Yeah, so if I can add to it, look, a lot of the industries globally have done a lot of things have benefited from AI. Retail is one of them, telco is another one, banking is another one. Probably it's been easy for them because of the nature of their business. I was having a discussion once with a gentleman in the oil and gas. We were trying to convince him to digitize and digitalize on Microsoft. The message was, listen, I'm a mechanical company. This is an oil and gas company. I get oil out, I send it to the ship goes out. Why do I need technology? It goes back to the original thing that I'm telling you. It's a mindset. We all know the challenges that we're getting. Here, you're going to have batteries coming in, interconnections coming in, EVs, solar, wind, a lot of challenges. We have to change the mindset. We cannot think about the future the same way we thought about the past 3 decades. If you change the mindset, you open up, you can look at things differently, and technology can play a very important role. If there's anything we can learn from any other industry, it's about how do they think about solving their problems, about creating, identifying those use cases, and mapping them into technologies. If you ask me, this is what I would look into the retail and the banking, because that's what they've done before. They've come and said, where should we be 10 years down the road? What are the biggest challenges we're facing? How can I start solving the immediate challenges that I have and learn and iterate? I think that's how I would approach it.
Yeah. So with all the conversation around AI and data centers, I'm hearing more and more that nations are looking at AI being a competitive advantage and even trending towards being a national security kind of context, about having that model developed in their country, having their IP staying in the country. Does this naturally lead to countries deploying data centers within their boundaries and actually localizing that development?
That's definitely happening already. It's happening here in Saudi Arabia, all over the region. More and more, you're seeing sovereign, national cloud providers popping up because of data sovereignty issues and data security issues. I think in the end, what it's all about is having access to AI, having access to it. And that these days is pretty easy, depending on where you are. Someone has it already. The question then becomes, and it's more of a financial one, how widely are you going to deploy it? How intensively are you going to use it? Therefore, you need to do the financial analysis to see whether you have it in-house, you continue to use a service provider, use Microsoft, whatever. That's a discussion, and I think it's something everybody has to have. As far as the data center business is concerned, I can tell you that at least one energy company I can think of is already very interested in providing that capability, the entire data center infrastructure. That's already taken place to some extent with some barter arrangements, but now it looks like Norway, for example, even Iceland, they're interested in putting data centers there because they have nice cold climate, plenty of empty spaces. Iceland has geothermal. Norway has really good hydropower facilities. So every country start to look at how do I provide the maximum access to AI that can help in all of these different areas within the country.
Right.
Yep. So I think if you look at Microsoft, so today we've announced that we're building a large data center in Saudi. So hopefully in the next 18 to 24 months, that data center should go live. We have a very big install base in both Qatar and the UAE. So when we build those data centers, I think this is giving our clients the comfort that their data sits in Qatar, managed in Saudi or in the UAE, and they're very comfortable with this. But honestly, I think even if the data center sits outside of your territory, there's certain data that could be open that maybe you would want to run it outside, and that is okay. There will be no harm. Keep your crown jewels in your sovereign country, but there are things that can allow you to benefit from cloud today where the data doesn't need to sit within the premise of the kingdom. So that's, again, part of the mindset that I'm telling you. What are the things that you can offload outside until the data center is up and running, and then repatriate it and bring it back into the kingdom? And that will give you the peace of mind. Maybe today, when you say about agility, let's try a couple of things. Try it somewhere outside, and then bring it back inside when you want to go into production. Because the learning curve will take you a couple of months, if not a couple of years. So let's get that skill running from now. But generally speaking, I think having the data centers within your country is a priority for us. We do understand it, and we definitely look to aggressively grow the install base that we have.
Okay, thank you. So what I'm hearing is AI is here. It's not a false start. It's here to stay. And the potential for AI to actually really help us in this energy transition is there. But we need to find a way to engage with the platform and the developers to actually develop those use cases, then find a framework where we can maximize the speed with which those use cases are developed and the capability of those use cases. And I think what we're hearing is it's up to us to engage with these companies and how we do that. So I'm taking away that that's a big opportunity for the industry globally and the industry locally to figure out a way how to engage and actually develop those use cases. So that is going to be, I think, the big opportunity coming out of this discussion. Understanding that this is a powerful tool, and actually we need to really, with vision and with focus, double down on engaging in there. So as we get to the end of this session, I'll just very quickly, a handful of things that we should do going away from these 2 days that would actually, in your mind, make you think we heard the message and we're setting ourselves up to make a difference?
Well, for me, it's to enable the smart grid, put intelligence into the grid, not only in the data center that's connected to it, but all parts of the grid have to have added intelligence. We have the mobile platform for that as well as the data center platforms. So my ask would be to seriously consider how you're going to make the grid more intelligent and more robust.
I think from our side is, it'll be very interesting to see if you can put AI as part of your strategic initiatives. A lot of organizations that succeeded in AI, it was part of the CEO's agenda. It was supported by the CEO and pushed from the top, bottom, and that helped create a lot of traction. So probably out of this, I'd love to see if you're doing things like smart grid, things on transmission, on the distribution, let AI be core to your corporate planning and strategic planning. And then that's one of them. The other thing is the people part. And the third, a center of excellence that allows you to bring AI into the discussions that you're currently talking about. If you're talking about smart grid or anything else, let the discussions happen with the center of excellence, these guys who can bring those AI and nice innovations. And let's talk and experiment and bring us into those discussions. It's always good to hear what we're doing. If you don't go and get the technology, at least you've heard some nice perspectives, and hopefully this is what we were able to do today as well.
Thank you for that. Just to close out, I'm reflecting back on the conversation that Bruce and Lumi had up here, where Bruce is talking about changing the engines in flight, whereas Lumi's building a complete blank sheet of paper. He's constructing the aircraft to fly new. Maybe this region has an unrealized opportunity with NEOM to actually go out there and develop AI tools and applications in the context of NEOM, which can be leveraged across the whole region. Just a thought. Well, with that, I want to thank the panelists. As I promised you, the smallest but the best. So I want to thank the two panelists for giving us their insights, and hopefully you learned something. I certainly did. So thank you.
Thank you.
Thank you very much.
Okay. I'm sorry, I think I surprised you there. I'm sorry.
Thank you, Engineer Neil. We would like to invite Engineer Ahmed Al-Zahrani, board member of GCCIA, for honoring the speakers and for a group picture. Engineer Neil Wimthurst, Senior Vice President of EPRI. Guy Gerritz. And Mr. Yusuf Jawad. Thank you, everyone. Engineer Neil, we will invite you in a few minutes for the summary remarks. We would like to invite again Engineer Neil, Senior Vice President of ERP, for his summary remarks on behalf of all the moderators.
Hello? Yeah. Thank you very much, and it's my honor to give my observations at the end of this very important event. And I really want to thank our colleagues, our friends, our partners at GCCIA for, again, working so closely with EPRI and just being such good partners in the region. So thank you very much. So this, again, has been a powerful forum, and I want to recognize all the people who've been watching online as well. So I gather there's a lot of people been watching the live stream, so hopefully people have learned a lot. I certainly have. So reflecting on some highlights of what we saw, I think going back to our Shad's keynote yesterday around, we've got to build something. We've got to do something. We've got to build what we know how to build. Solar, batteries, nuclear, whatever you might think it is. But that won't be enough. That will get us some of the way, but we need new technology, and we need to pilot that technology at scale to get to that nth of a kind deployment. And remember the takeaway he gave you. Does this region have an opportunity to do some of those pilots, to lead those pilots, so that the example from what's done in this region can be shared around the world? So that's one thing I took away. And then I think Neva said it a few times in her panels, because there were several Neva panels, and well done, Neva. And it went through many of the panels, collaboration. You can't do this alone. We talked about the AI panel just now, finding a way to collaborate in AI. Collaboration is difficult. That's why we tend not to do it. But this time, this energy transition, we're only going to get there if we collaborate. And I think we've got the great platform here in the GCC region for collaboration. And I can see so many opportunities for collaboration beyond this region. I'm looking forward for EPRI, GCCIA, and others working together to broaden this collaboration outside of GCC region and into the rest of the world. So I think there are many lessons that the rest of the world can learn from the energy transition in this region. So I think that's another thing I took away. Going back to the panels that Daniel led, couple of things in there. Flexibility is going to be really important. And you build into that flexibility combined with resiliency and reliability. We've got to keep our eye on the ball on flexibility combined with resilience and reliability. As we get to this solar world with sandstorms, climate change, everything else, what does it look like managing that grid? And that leads into the final one, which I think is the wraparound for the whole day and a half, managing complexity. The world is getting more complex. The grid is getting tremendously more complex. How do we manage that complexity? And it's collaborating around what we do, sharing what we learn, and just again to reflect on what we heard a few minutes ago up here, AI has a big part of this to help us manage and control and understand the complexity. So there's a lot there. I truly believe that AI discussion tees up a possibility for the GCC region, maybe EPRI working with GCCIA, thinking about those use cases and how we can collaborate, bring people together, and actually bring some of those use cases to fruition. So in closing, thank you so much for the event, for the incredible hospitality which I've come to appreciate more and more over the years in the region. And thank you for the friendship from all our partners in the region. Thank you very much.
Thank you so much. we would like to invite His Excellency Engineer Ahmed Al Ibrahim to close this wonderful two-day forum. Welcome to the stage.
Assalamu alaikum wa rahmatullahi wa barakatuh. Well, thank you, Neil, for summarizing some of the takeaways that we had over these nice 2 days. I think in addition to the 2 days of nice discussions, we had a nice dinner last night where we have explored the talents of some of you in performing some of the traditional Arabian art. So I hope this is something that you have also gained from this participation. So we continue our journey of collaboration with IPRI, which we started in 2019. It's a journey that is more and more emphasizing the collaboration and the importance of having such partners to build for the future. I think the continuous commitment and dedication of IPRI is more and more reflected in the future. I have been selected as an IPRI board member, which emphasizes this mission of IPRI of becoming global, of having global representation. And one of the initiatives, important initiatives that IPRI is having is the establishment of IPRI Gulf, which will be really focusing on this region and the potential and the commitment of the GCC in this field of collaboration. And I think we are building more and more, this kind of work for the future. I think the dedication of IPRI is very important. I think we see the existence or the attendance by Arshad and the senior executive VPs from IPRI that reflects really the commitment that IPRI has in this region. So I'd like to thank IPRI for this partnership, and we are building for the future. We will continue our journey with all of you. We'll all have to collaborate, and I think we've heard this on the panels, that we still need to collaborate more. We have to work together as one team towards the future. The future is very challenging, but there are lots of opportunities, and we can grab these opportunities and be ready for the future only by working together and building our future on new technologies and new research. So again, thanks to all of you for being here, and we hope that we will be seeing you in future events, because we promise you there's more to come, and we count on your participation and support in this. Thank you very much, and have a nice lunch.
There is a group photo, please join. All the teams, please.
Thank you for your attendance, and please enjoy the lunch on the first floor. Thank you.